Okay. Good morning, ladies and gentlemen. So I welcome you all to the fourth day of our short-term course, Chemistry for Engineering Applications. So again, today we have two sessions, and for the first session, we have Professor Shishir Sinha from Department of Chemical Engineering, Indian Institute of Technology, Roorkee. And for second session that starts at 2 o'clock, we have Dr. Jayamurgan Govindaswamy from Institute of Nanoscience and Technology, Mohali. So to start with our first session, I would like to invite Professor B.S. Kath, Head of the Department of Chemistry, NIT Jalandhar, to kindly welcome and introduce our speaker for the first session. Thank you, sir.
Thank you, Rakesh. First of all, I must welcome Professor Shishir Sinha, who is from IIT Roorkee, in this short-term course being organized by the Department of Chemistry and NIT Jalandhar. Welcome, sir, to this STC.
Thank you, sir. Thank you.
Professor Shishir Sinha, he presently is the head of department head of chemistry department at IIT Roorkee. Professor Sinha is working on blended polymer composites, polymer surface modifications, polymer composites, nanocomposites, and ion exchanges. Professor Sinha did his BTech in chemical engineering from HBTI, Kanpur in 1993. He did his MTech in chemical engineering from HBTI, Kanpur in 1995. And did his PhD in chemical engineering from IIT Kanpur in 2000. From 1993 to 2003, the Professor Sinha served as lecturer in Thapar Institute of Engineering and Technology, Patiala. From 2003 to 2006, he was promoted as assistant professor in Thapar Institute of Engineering and Technology, Patiala. And 2006 to 2009, Professor Sinha was assistant professor at Indian Institute of Technology, Roorkee. And 2009 to 2014, Professor Sinha served as assistant professor in IIT Roorkee. And from 2014 onward, Professor Sinha is full professor at IIT Roorkee. Professor Sinha has produced many PhDs and MTech students. He has delivered innovative talks at several places, including University of Utah, and he has delivered expert talks in many conferences, and around 100 research papers are there in various reputed international journals to his credit. And Professor Sinha has authored many books like Polymer System and Application, published by Studium Press LLC, Biodiesel Present, Past and Future, published by Quality Improvement Program, IIT Roorkee, Advances in Polymer Science, 2011, and Compendium on Nanotechnology and Electronic Waste Management manuscripts, which is approved for publications. Professor Sinha is a renowned academician, a renowned researcher, and a renowned scientist, and a renowned technologist. I welcome you to this short-term course, sir, and I request Professor Sinha to deliver his talk, and I am sure the participants will get benefited out of the talk of Professor Shishir Sinha. Welcome, sir, to this short-term course.
Thank you, sir. Thank you, Professor Kath. Thank you, Professor Rakesh, for inviting me for this particular talk. And just I had a discussion with Professor Kath regarding the topic of my topic. So I was a bit interested to give a topic which is more relevant nowadays. This is related to the typical waste management, and the waste management is a very unconventional waste management, that is electronic waste management. Just I am sharing my screen, and then we'll go ahead with the what you can say, the detail. Just I'm sharing. There's bit problem.
So you go to present now.
Yeah, I am very much here in present now. It is giving the entire screen. Yeah, it is.
Entire screen पे है sir.
Yes. Now I think it is
Yeah.
visible.
It's visual, sir. Visual. Full screen पे
Right.
है sir.
Right.
Okay now, yes sir.
No. So thank you very much, Professor Kath, for giving my introduction and also inviting me for this lecture. Just I have chosen this particular topic, that is electronic waste management, and it is more, I guess, that the participants from across country, they are very much related to the chemistry or engineering field. Now, electronic waste management is a buzzword nowadays. The reason is that if you see that for last 6 months, we are having almost 90% of our official activity through online mode. Maybe through your laptop, maybe through your mobile phone, maybe, or some other media. Even I am, while presenting this lecture, I am using more than half a dozen electronic gadgets, either put on my right hand side or on my left hand side, slide presenter, mouse, stylus, one digital display board, and laptop. So this particular concept opens up a wide spectrum of opportunities for either scientists or engineers. Now, why I'm saying the vast spectrum of opportunities, because as a user, as a consumer, we always intended to have an upstream thing. Upstream thing means we are using mobile for our use, but we never bother about that what will happen when it completes its useful time or usefulness for me. Similarly, I am using, say, i7 10th generation laptop. Suppose in any point of time, i9 10th generation or so and so on, or higher version may come into existence. I'll just throw my old laptop to somebody else. So this creates a lot of problem, and we are not, properly visualizing this particular problem. But sooner or later, we will realize that it creates a lot of hiccups in our day-to-day affair. Similarly, in our day-to-day affair, we are using so many electronic gadgets, whether it is a refrigerator, microwave, oven, even television, etc. And sometimes after, say, this LCD display panels, LED came into existence, and then now people are talking about OLED. So based on the variety of factors which we are going to discuss in this particular lecture, there are a lot of opportunities. So don't think that opportunities are always exist in upstream thing. Opportunities always exist in the downstream thing. Now, downstream here we may list like the disposal of these electronic items, disposal of the accessories, even proper management of all those electronic gadgets, etc. So a lot of things come into our mind that, suppose just to try to synchronize your mind in such a fashion that suppose you are having, say Samsung S10 mobile with you, and sometimes based on your affordability and based on your use, a new version may come like Samsung 20 plus, etc. Then what will happen to your old mobile phone? The easiest way is, yes, just to throw it away to or just give it to your either vendor to get some money in terms of exchange, or donate to somebody else, etc. But as a scientist, as an engineer, have you ever thought that what happened to this particular product when it completes its shelf life? I will discuss about this shelf life aspect in due course of time. Also, we will discuss about the life cycle assessment of all these aspects. But it opens a new horizon. Suppose you are having a sustainable technology for the management of this particular electronic item, then definitely you are king nowadays. So give an impetus, give a synchronized thought to this particular idea, and go ahead with what the people are talking in respect to the electronic waste management. Now, do you know that today's electronic gadgets, they are tomorrow's electronic waste? Now, just give a serious thought or a deep thought to all the lines. Like today's electronic gadgets, today there is a boon. They are boon. Like without mobile, you cannot perform your banking operation. Without mobile, even the student nowadays, without mobile or a laptop, they cannot study, because at IIT we are having this semester completely online, like other institutes. So people must have at least either mobile phone or laptop or a desktop, whatever. But what happened when, for me, for you, it completes its usefulness? Then it will become the waste material. Now, waste material, again, they are having very broad definition. Why I'm saying that it's a very broad definition? Because see, I am technology freaky. Then definitely when a new mobile phone comes into the market, then definitely I'm intended to buy it, whether it is useful for me or not. It's not the question of usefulness. Sometimes it becomes a fashion symbol, sometimes it becomes the status symbol, and sometimes it becomes the necessity. So for me, it may become the waste, but for some other people, it may become a useful item. But what happens when this cycle, this chain ends? So we must define that what is the electronic waste. We must define our life cycle assessment concept. We must define proper methodology for disposal of these items. All of you are carrying the mobile phone with you. Have you ever thought that what is the composition of this mobile phone? The reason is, you see, all of you are probably chemistry people, that there are so many polymeric things are associated with it. And while developing those polymers, while assessing the properties, there are so many hazardous components inherent to it. We always talk about the radiation level to these mobile phone, but never ask about that what is the composition, how it is dangerous to our lifestyle. So there are variety of questions should come into your mind. And based on this, you must define your electronic waste, you must define the classification, you must define all other aspects for the life cycle assessment of this electronic items. Now, question arises, what is electronic waste? Sometimes people may say that any electronic equipment, any electronic equipment which is discarded at the end of their useful life cycle or due to technological advancement. Again, it's a very debatable question. The debatable question in the sense that who will decide that what is the useful life of that electronic item? It's me, who is the user. Sometimes, I mean, see, i5 or i3, they are useful for somebody else, but for us, it may be it may be a discarded thing. Similarly, because this useful life is always attributed to the technological advancement, so every time you will see that new electronic gadgets, they came into existence, technological advancement plays a very vital role, like washing machine, like televisions, etc. So they ranges from household appliances like television, refrigerator, etc., air conditioners, to consumer electronics, to computer. So these all, this is the very wide spectrum of these electronic gadgets. Now, one thing we must remember, that the production of electric and electronic equipment, this is one of the fastest growing business in the world. And nowadays it gains more and more acceleration because of the necessity of the online approach. And you may recall that there are certain other drivers to this particular business. One is the embargo with China. That's why you may see that the cost of these electronic gadgets are increasing day by day. And sometimes some new technological innovation may play a very vital role to this market expansion. Now, see, one study was carried out by United Nations Environmental Program that every year almost 20 to 50 million tons of electronic waste are generated worldwide. And you can easily see in the right hand side of this figure that this type of junkyards are becoming more and more common across globe. And trust me, this junkyard, which the picture is given on the right hand side of your screen, is from India. Now, again, people may ask that what is the definition of electronic waste? It's a very complex to define. I told you at the start of this lecture that sometimes for me, I7 is a useless thing, but for somebody else, it may be a useful device. So there is no standard definition. Every country has its own definition of e-waste and how they call the e-waste. And sometimes, those who are more than 40, 45 years, then they may recall that when during our graduation, the photocopying machines, the electronic photocopying machines were more common, and all these machines were used to import from Taiwan. The reason was that in a certain developed country, they, after a certain a period of time or certain period of a certain count of copies, they are intend to discard it because of certain maintenance issues and etc. So there are certain underwriters, though in Taiwan, they used to procure all those second-hand machines from developed countries. They refurbished it, they recycled it, and then they sold to the developing countries. But after 2000 or 2006, it is banned just because of the Basel Convention. So transboundary export of these hazardous items or these items are banned. But still, some people are even contributing in a more legalized way. Like Apple, they previously they were intent to have one manufacturing unit in Chennai for the refurbishment of their used Apple phone. Usually they got it from exchange of various US citizens. So this particular concept is it's like a balloon. So again, the question is that what is to be called an e-waste? Some people may say that any electronic or electrical appliances which are obsolete in terms of functionality. That is absolutely true. That is a concept covered under the life cycle assessment. Then the product that are operationally discarded. This is a very important thing, because the operationally, for me, the old Samsung phone is usually operationally discarded. That depends on either psychology, that depends on affordability, that depends on various other factors. And sometimes you may call as both. So I'm not going to detail about the various definitions been put forward by various agencies, like American definition, any electrically powered appliances that no longer satisfied the current owner for its original purpose. Again, I've told you that the original purpose is a very broad spectrum, sometimes psychological. New mobile phone came into existence, then the marketing gimmick forced you to purchase this one. Similarly, the European definition, again, European definition based on various country to country. Right. Now, before anybody can take up the proper methodology for discarding the things, they must classify the waste, so that they can adopt for the proper methodology. Second thing is that they must know that what are the ingredients in it, so that they can follow the proper protocol for the treatment of all those electronic items. So people have attempted in so many ways, and sometimes based on the usefulness, sometimes based on their use, they can be categorized either in a telecommunication waste, comprises of mobile phone, telephones, etc., electrical waste, electronic waste like metal waste, printed PCBs, etc., cable waste, etc. So the classification is having the wide spectrum. In domestic level or in a user front, we can again classify in downstream approaches like home, different type of things which we are using in our day-to-day affair, like PC, television, radio, cell phones, etc., hospitals, government organizations. I'll give you another example of our IIT that we used to discard, and sometimes we used to donate all these old computer to the Nagar Nigam or local bodies for the economically weaker section of the students, so that they can utilize. But we never bothered that what will happen when they complete their usefulness on their platform. Then there are certain private sectors like restaurant industries, etc. They may have a PC, boiler, mixtures, etc. So there are the spectrum is wide, the classification is wide. Now, in a layman's language, you can see that what are the different electronic items, or you are surrounded by the different kind of electronic items. Some of them, they are represented in this pictorial diagram. Now, the second part of this particular aspect is that what is the composition of e-waste? Now, when we talk about the composition of electronic item or electronic waste, they are having the twofold of composition classification. One is based on that how many chunks they acquire in our day-to-day life. You can see that in the large household appliances, they graph almost 42%, IT communication technology more than 34%. Now, why I'm saying this more than 34%, and this particular ratio or this particular percentage is having the varying concept, because IT industry is growing up, consumer electronics industry, they are coming up, large household appliances, they are coming up, because when we are talking about the machine learning, when we are talking about the internet on things, then you cannot overlook the importance of those electronic items in your household appliances. So the question first, before we deal into that, how we can minimize, how we can deal with such kind of electronic item, let's have a look about that how this e-waste is generated. Now, some of things we have already covered in the past couple of slides. But here, sometimes there are certain other hidden facts which one should know, that sometimes manufacturers need to use certain chemicals, element, compounds to synthesize a final consumer products. That based on the consumer acceptability, that based on the consumer desireness, and that based on the aesthetic sense. The best example is that in the market you may see that there are several mobile phones or several computers, those who are available, like magnesium body, aluminum body, plastic body, etc. Similarly, if you go for an autopsy of those items, you may find there are certain plastic components, PCBs, etc., which are as an allied part. So sometimes it is being compelled by different aspects to the manufacturer that they need to go for varying composition of all those chemicals element for the development of their product. So that is based on the years of R&D, multiple product generation, consumer aspect, etc. So based on this particular aspect, they are compelled to develop a new product. Now, before again going into further detail, let me give you another statistical information, that the top 5 e-waste generating countries in the world: USA, China, Japan, Germany, India. So we are number 5, right? But if you see that the countries with the biggest number of mobile phone users, we are silver medalist. Right from China. China is gold medalist and USA is the bronze medalist. But don't think that we are more progressive. The reason is the population. Reason for this large number is our population, and that's why it is attributed by the China. And trust me, we are just surpassing, we are just approaching to the China. just because let me take the liberty to give you another thing, that based on our requirement, based on our status symbol, based on other things, people may have 2, 3, 4 mobile phones with them. One person came into my office last year. He was having 4 mobile phone with him. Even sometimes in our household approaches, we may have 2, 3 laptops in our day-to-day life. So all these things are major contributor for generating this particular approach, right? Now here we are having one more statistical information from SOCHM KPMG study, that Mumbai is right on the top of generating e-waste. Mumbai, then Delhi and Bangalore. Now the reason is that all these 3 countries are either 3 cities are commercial hubs. Bangalore is the IT hub of our country. So based on this particular thing, and they are also compared to change, to adopt the change, and they are usually adopting those things, and they are again discarding. Bangalore, there are so many industries, almost more than 105 industries. They are involved themselves in churning of all those electronic gadgets, and some of industries, they have signed with different banks, they have signed the MOUs with the different restaurants, etc. I'll give a brief outlook of those in later part. Now, let's analyze, or let's imagine, or let's visualize the gravity of e-waste. 50 million tons of e-waste produced globally, and 0.8 million ton is contributed by India. So when we talk about our Atmanirbhar Bharat, then definitely we have to look this figure also. Now in India, 90% mobile equipments are imported. Fortunately, we are decreasing this particular percentage day by day, just because of the concept of Atmanirbhar Bharat. But another dim figure is that India is the largest importer of e-waste. If you see your mobile phone, if you see the laptop, if you see your television, if you see other gadgets, they are having more than 50, 60, 70% items manufactured outside, either Taiwan, China, Japan, Korea, etc., and even USA. So the rate of electronic items, or use of electronic items, or e-waste generation is increasing almost 10 to 12% every year, duly supported by our population, duly supported by our societal expectations, duly supported by our affordability. By 2021, approximately 50 billion devices will be connected to internet, and the acceleration is attributed to our COVID-19. Now, you may see the problem is severe. One statistical information we collected from United States, that between 2008 to 2019, nearly 950 million personal computers became obsolete. Almost 2 computers for each person. 7 million computers will end up stockpiled for at least 3 years, and 7.5 million computers will end up in the landfill this particular year alone. Let us have a look about the growing electronic industry, electronic and electrical equipment industry in India. As I discussed, that information and telecom, they are the fastest growing business in country. They are fastest growing verticals. PC sales is increasing day by day, growing day by day. Internet connectivity is going day by day. Consumer electronics market is growing day by day. And one very interesting figure is that cellular subscribers up by 96.86% over last year. The reason is the online approaches. Now, don't forget, another major contributor to this is the COVID, because of this online approach, online factor. Now, online, every time we used to say that that while working the computer on a computer, working through the mobile phone, etc., it is the only domain of online. It's not. The reason is that if you see in your day-to-day affair, for last 6 months, we are quite resistant to hire the domestic help. We are not allowing them to come into our house just because of the infection. So sometimes the cleaning of utensils, almost 20-25% people are thinking to buy a new dishwasher. I'm giving you a small example. While you're purchasing the dishwasher, that means you are inviting one electronic waste to your house. It not only provide an ease to your day-to-day affair, but also it creating a e-waste dumping approach. Anyway, this was on the lighter note. Similarly, you can visualize that there are so many other aspects associated with this e-mode or online mode. So that's why the corona is again the one of the accelerator for this electronic waste generation. So in psychological aspect, there are 4 broad reasons for generation of these electronic waste. One is the advancement in technology. I have already discussed this thing that sometimes because of the usefulness and because of the compulsion from other approaches, like if you are having the VGA or a system with you, or if you are having a black and white mobile, or if you are having the old Nokia 5110 mobile with you, you can't even perform the banking operation. So advancement of technology is attributed for the generation of these electronic waste. Another one is the change in style, fashion and status. This is again a very contributory thing, the generation of electronic item, because see, if it is affordable to me, then definitely I am intended to buy a new mobile. I am intended to buy to purchase a new laptop, new television, new washing machine, etc., and so on and so on, because it's a open-ended market. The third approach is that nearing the end of their useful life. Now, this particular approach invites a lot of debate. The reason is that suppose I, as an engineer, I am intended to have the computational aspect. So every time I'll be focusing to have more and more advanced computer with me. That means whatever computer I am using right now, or whatever computer I was using in past, they lost their useful life. Similarly, if I am having 5110 mobile Nokia mobile with me, then for me it's not useful, but it will be useful for person who is only interested in talking. If I am interested in surfing, if I am interested in mobile banking, if I am interested to use the different kind of apps, then it is of no use. So that means for me it ends its useful life, but for some other person who is having only interest in talking or a communication, then it may be useful for them. So that's why it's a very debatable term. The last approach is that not taking precautions while handling them. Sometimes we are very casual, maybe throwing away to the dustbin, maybe throwing away, maybe sometimes it drops to the thing. So we don't follow the usual protocol for handling all those devices. So this may a small contributor to the generation of electronic waste. Apart from this, there are some organized sources of electronic waste. One is that individual and small businesses, they usually discard it, not because they are broken, but simply because of the advancement of a new technology. Like in IIT, when I joined, then when I joined my PhD program at IIT Kanpur, the XT was a luxury at the moment. But nowadays, nobody talks about the XT. Neither Pentium, neither i3. Some people may talk about the i5. Some people may talk about the i7 older generation. Now everybody is talking about, so I am having i7 10th generation, I am having i9 with me. So individual and small business houses, they discard because because the advancement of new technology, and sometimes we compel to use this a particular approach. There are certain large businesses, institutions, and governments. They upgrade the employee regularly, say every 3-4 years. So when we talk about the 3-4 years, that means we are having the shelf life or useful life of that particular electronic gadget 3-4 years. And usually, if you are working somewhere, if you are working for say last 10 years or 15 years, then I guess my statistical figure given to you that 70% are discarded is true. There are certain original equipment manufacturers. They generate e-waste when the production lines sometimes they don't meet the quality standards. Then they are compelled to discard because of the certain inventory issues. Imports, I have already discussed that almost 80 to 90% of e-waste generated in either developed countries, they are exported to India, China, and Pakistan. Nowadays, this figure is having the declining trend. The reason is that there are so many regulatory issues. They barred those transboundary import or export to developing countries. Now, we are coming to the gravity of this electronic waste and impact to our day-to-day affair. You see, the basic material composition of e-waste is given in this particular slide, where you will find that almost 57. And remember, don't trust about this 57, 22, 9, because these are variable and they depend on your electronic items. But the purpose of this particular diagram is that if you are having 57% of metal in that particular electronic waste item, then it gives you enough opportunity for job creation. It gives you enough opportunity for the feasibility in terms of the treatment of all these electronic items. So this gives you another downside approach of economics. And trust me, almost 148 companies, they are involved in India for the treatment of these electronic waste generated by various organizations, and they are minting money just like anything. Please mute your mic.
Hello, Mr. Hasimur Rahman. Can you mute your mic, please? Hello.
No.
Mr. Harim, I think I should remove this person.
Now, the question arises why this e-waste is a problem. See, this particular slide says that a rapid technology changes increase the consumer electronic purchases, and sometimes more and more e-waste are generated. That means the consumption of more hazardous materials, either maybe in the landfill, or sometimes it may increase the human health issues. So these two aspects, that is the consumption of more and more hazardous material and increasing the human health risk, I will focus on it in my lecture. Now, trust me, when we talk about that, yes. Is it indeed?
Yes, I was just talking to.
Okay, sir. Okay.
Yes, sir. Please go on. I was just trying to. Sorry.
Now, is it indeed hazardous? See that the e-waste contains several different substances and chemicals, many of which are toxic in nature, and they may create adverse impact to our day-to-day life and a human life. You can see these figures. You can see now. You can visualize the gravity of this electronic item. Now, question arises: what are those toxic substances? Even you can see, because all of you we belong to the scientific community. We know that certain essential chemicals, certain essential hazardous chemicals are used to fabricate all those electronic items. Another thing is that when we talk about the certain word, again, it's a very debatable. Everything is hazardous, including water, what you take. The only thing is that the way through which you are taking or the amount you are taking. So excess of anything is always dangerous. So the things are that how many toxic substances are present in e-waste. There are many harmful, like lead, cadmium, mercury, plastics, etc. And you can see, I don't know whether it is clear or not, that almost 23% plastic, ferrous material, 20% aluminum. These are the rough figure. Then silica glasses, etc. Nowadays, people are talking about the gorilla glasses, AMOLED screens, etc. So all these are having the different chemicals as an ingredient. So it's not the deteriorating picture, it's a very, you can say, the favorable picture, because when the chemicals are being consumed, as a chemical engineer, as a chemist, we are always happy, because it gives enough opportunity for economics of our profession. And simultaneously, when they are contributing towards the electronic waste, then again it gives an opportunity that we should extract all those material for the recycling purpose or refurbishment purpose. Here you can see that different e-waste toxic component, their damage to the human health, like barium, cadmium. In the left hand side, the column says different type of chemicals being associated with your electronic items, and the different effects, different defects, you can say, to the human health, like birth defect, brain damage, heart, liver, lung, etc. Probably 50% of you are, I mean, in this particular frame, that the radiation is the only cause being attributed by your mobile phone, but it's not. You can see the kidney damage, nervous, reproductive systems. There are so many things are associated with the negative part of this one. In this particular slide, you can see that different constituents, where you can find these constituents in your electronic item, and different health effects, like lead. They are the integral part of PCBs, glass panels, brominated flame retardants, BFR, cadmium, etc. And they may attribute different type of health effect to your adverse health effect to your body system. Similarly, mercury, hexavalent chromium, beryllium, there are different type of adverse effects you can see, you can visualize, and it's not instantaneous, because they may become the part and parcel to your body system in a different way. I'll give you a chart through which you can analyze that how they can become the part and parcel of your day-to-day life. PVC, barium, these are the certain other chemicals which are having the different aspect of your electronic items and their impacts. So the question is that how they can associated with our body system. Second thing is that how they can adversely impact our environment, and do we have any sustainable technology through which we can treat all those things. First thing is that let us discuss about the environmental issues, like if you burn your plastic material, if you burn your mobile phone, then emission of dioxin, extremely dangerous. Heavy metals, lead, cadmium, they can discharge into the atmosphere. And trust me, the people are committing this type of mistake in our country too. I'll give you a picture of this one. Other contaminants like BFR, spent fluids, groundwater contamination may create a severe problem. There are certain non-recyclable things, they are contributing to the landfills or leachate, and then they become a part and parcel of our day-to-day affair. Before we go into the methodology, let me give you another picture, like plastic, lead, cadmium, chromium, mercury. How much quantity they are contributing if you discard 500 million computers. This is one statistical rough figure. You can see the gravity of those discarded electronic items. Then you see that in Indian scenario, still we are having some obsolescence rate of computer, television, refrigerator, washing machines, etc. Computer 5 year, television 7 year, refrigerator 10 year. It's a very rough figure. That depends on the demography. Now, demography means, suppose if you are living in Noida, if you're living in say Chandigarh, Delhi, etc., then the obsolescence rate may be low compared to refrigerator. You may intend to have a shelf life or a useful life of 6 or 7 years. So it all depends on the various factors which we have discussed previously. See again, information research group, they carry out one study that top 10 states, Maharashtra, Tamil Nadu, Andhra Pradesh, Uttar Pradesh, they are contributing a lot in terms of electronic items. The things are becoming more and more severe while inventing more and more new electronic gadgets, items, etc. Now, important things that how we can discard these electronic waste. There are two ways. One is the conventional way, another one is the synchronized way or professional way. So the conventional way suggests, like this photograph is from one site at Moradabad. They are having 15 square kilometer of area where they are treating these electronic items, waste electronic items, in a very crude manner. I'll show some of the photographs. Now, this is the photograph when they extracted all the useful things based on their discretion, and they dumped all those things to this to adjacent to the one local river. So one of the easiest method for this non-scientific method, and this particular dumping thing is illegal nowadays. So the landfilling, this is the most common methodology of e-waste disposal. Soil they used to excavate, trenches they made to bury all those electronic waste. Sometimes may or sometimes not, an impervious liner is made of clay or a plastic with a leachate basin for the collection and the transforming of e-waste to the treatment plant. This is not, you can say, the eco-friendly practice. Now here another conventional method. Another conventional method is the incineration. Usually it is performed to extract the metal part of those electronic item, or sometimes if you perform some in a regulated manner, you can extract some precious material. So usually this involves the combustion of electronic waste, and usually people are adopting the two methodologies, primitive and formal. Primitive means that e-waste can emit the toxic fumes and gases. I told you that dioxins, etc., they can emit and they can discharge to the atmosphere and create a problem to a certain peripheral population. Now, the creation of these harmful gases to the atmosphere sometimes may cause carcinoma, sometimes other health impacts, etc. Another one is the open air burning. This is very prevalent in certain Asian countries. They burn the plastic or a polymeric component to recover metal parts. And PVC, all of us are aware that when they burn, they found the dioxin and furans. So sometimes high level of cadmium, copper, etc., they may create a lot of problem while burning in an open environment. So one question must be triggering your mind, that do we have any kind of a controlled way through which we can perform this operation? Yes, we have. And this is the formal technique of the incineration. This is the controlled way of disposing all kind of electronic items, electronic waste. Usually it involves the combustion of electronic waste at high temperature, and you can see that there are furnaces associated with where you can collect all kind of toxic gas. You can treat it, you can scrub it out, all those things. So this is the proper protocol through which you can treat those electronic items. But the question is that people are not adopting this thing. We will discuss that why people are resistant toward or reluctant towards this particular approach. Another conventional method is the acid bath. Usually it involves the soaking of any kind of electronic circuit so that they can extract the metal, sometimes silver, sometimes copper, sometimes even gold. So the recovered metal, which is used for the manufacturing of other products, while they intend to discard these acid waste into the local body, local water source, drain, municipal sewer system, etc. Thereby they are creating a problem to the larger population. There are certain challenges and certain problems are associated with the disposal of these items. Now this suppose like see if you see the first figure, this landfill disposal allows heavy metal to leach into the groundwater system. Now the gravity is like that, the groundwater is having the migration ability, and that's why you can see that your domestic wells are having the tendency to replenish after you extract the water. So when any kind of heavy metal it leaches into the groundwater, then it may create a problem for the larger population. Similarly, incineration makes the hazardous material, if you see that the second figure photograph, material airborne. So acid bath are dangerous, causes the water and soil contamination, and these kind of materials, they are utmost requirement by either by the regulatory body, either by the local bodies, to be very carefully. Now, let me give you a brief glimpse that what are the existing waste management practices in India, like plastic waste. And trust me, almost 90% of electronic waste are treated in such a crude way. 10%, we are having only 148 units as on date in India for this synchronized way of treatment. Now, the plastic waste, usually the product if made from plastic such as keyboards, casing, etc. Usual management practice is that shredding and melting. Now, shredding and melting both are having the two-way. One is the formal, another one is the primitive. So people are adopting primitive way. Just they are melting all those things, just grabbing those polymeric parts, whether they are cross-linked or whether they are linear polymer, irrespective. Then PCBs. Usual manufacturer practice is desoldering, open burning to remove the metal, because they are more interested of having those precious metals associated with them, because they are having their resale values. There are certain miscellaneous waste like chips, electronic wires, etc. Again, the usual practice is that chemical stripping, open burning. So these are the wide spectrum of various practices. Liquid waste, the easiest way is to throw it away to the municipal sewage system. Now, just again, I'll show another photograph. This photograph was captured in one site at Muradabad. The person he is involved in melting of the plastic or a PCB to extract the metal part. See, he is directly exposed to this open air burning. So that's why it's a poorly regulated operation and have resulted to the toxic hazard. He is not putting his life in danger, but also creating the others into the danger scenario. Similarly, the e-waste recycling you can see this particular person is just extracting the precious metal parts in a very crude way. So there are certain deficiencies in our system. That is, there is no organized collection system, right? See, you can give a thought to your mind that when I talk that if I am intended to discard my mobile phone, the easiest way is that either go to the local vendor local mobile shop, just get some exchange value and purchase a newer one, right? So there is no logistic, or there is no proper collection system. We never bothered, we never question anyone that what will happen to this particular mobile phone, what will happen to this computer when they completes their useful life, not our useful life, their useful life. So there is no organized collection system. Usually you see that these operations are illegal, though we are having very synchronized, very systematic, very scientific approaches through which we can treat all those electronic items, electronic waste, but we are not adopting. You can always visualize through the various photographs shown in this presentation that process is highly polluting. Usually dismantling, sale of dismantled part, valuable resources recovery, and whatever you are having left over, just melt it to grab certain kilos of plastic material. Now another you can say, in other word, you can say this is a socio-economic factor of all those things, that in e-waste recycling in the industrial area like Okhla in Delhi, you can see that it is a clandestine operation. Tons of e-waste lie hidden behind the high fenced wall. They need to carry out round the week for over 12 to 14 hours a day for just 500 or 400 rupees per day. Now, when I am presenting this statistical hours, that means they are not following the normal government rules. Within these squatters worker, you can sit on the ground among the piles of the computer parts, separating them, performing various operations, including acid bath, including burning, etc. So they are putting their life as well as others' life in danger. Another another thing you can see, that the informal recycling, it deals with the high risk of backyard operation, non-efficient, nobody bothers, non-eco-friendly. Occupational and environmental hazards are always there. Loss of resources due to inefficient process, and that's why I am saying that all of us are having the scientific background with us. We must try to develop certain methodology through which we can treat, and we can develop a low-cost treatment protocol for this electronic waste item, because this will the use of those electronic item will increase in an exponential manner. You can see some improper handling, and we are not far away from China. You can see the Chinese girl playing with electrical wires, and man in India having the old CRT monitor tube. This is handling this one. So there are various issues and challenges attributed or associated with this particular approach. One is you can start from any point, like the psychology impact, etc. So that's why we are committed for the less use of those items, and simultaneously we are less reusing the things, because usually we are not questioning the things, that what the vendor will do for the exchange of these items. Sometimes it may be discarded, sometimes may be created other environment problem. So people are intended for the less reuse, and I can equally blame our scientific community that we are not mobilizing our efforts to promote the reuse of all these things. We have already discussed that we are having very poor collection system. We are not having the proper logistics. That's why we don't have any clue about that, what we will where to dispose, where to deposit all those old used mobile phones. Then legal framework. Again, it's a very debatable thing, because we do have certain laws in place. We are having the laws with us, but the problem is that the enforcement of those laws, if we are rigorous to this enforcement, then definitely the picture which I showed you earlier, they will be the history. But unfortunately, because of certain allied factors, we are failing to do these adopting these legal framework. And moreover, the developed countries, they are very much ahead of us because they are rigorously enforcing all those legal frameworks. We will discuss certain lacuna in our legal framework in the later part, in the concluding remark. Now, another very important thing which I'd like to discuss, that how to dispose the e-waste. You may have, see, suppose if you are having any old mobile phone or a laptop, either you donate it to somebody else or your relative, somebody, kamwali, etc. Or sometimes in an organized sector, we used to donate all those equipment to the either school, college, government entities, etc. Sometimes we return them back to the manufacturers, but it's a very limited practice in our Indian context. And the most prominent one is that to we can send it to the authorized recycling facility. Fortunately, in Uttarakhand or near Roorkee, we are having one e-waste recycling facility, but that is a physical one. They are just dismantling and they are just reselling all those things. So how we can deal with this electronic waste items? As a scientific community, we can adopt the practice of inventory management. We must not have, we should adopt the milkman policy. This milkman policy is very common in Japan and very common in other developed country. The milkman policy is a very simple policy. They are having a very regulated amount of warehousing, where they are not keeping their raw material in a stockpiled manner. Once they require their raw material, only then it used to arrive to their manufacturing site. So they are having very proper environment management. They are having a very rigorous production process modification. Just they are minimizing their ways of product modification, and they are minimizing their effort so that the less harmful approaches may come into existence while the process is on. Volume reduction, and most important is that the recovery and reuse. And that's why you can see the recycle, reduce, reuse. These are most, you can say, the psychological term, and you can see the several developed cities, they are having this type of logo in their different play cards and logos in their different posters, etc. We must have 4 basic principles or 4 R's in our system. One is reduce, reuse, recycle, and respond. Now, by this way, you can minimize the volume of your waste. You can reduce the waste and the pollution, because when you are having the less amount of a waste, then simultaneously you may create the less pollution. Our methodology as a scientific community should be that to reuse as many as things possible from which. And one more thing should be triggered in our mind, that we must know that whether this particular thing is useful or not. If not, that only then you should discard it. Otherwise, you can use up to its shelf life. Recycle and compost as much as waste you can, chemically or biologically. Bury whatever left, but in a synchronized manner. Right, and respond to your legal framework. Remember, every country is having the legal framework. Even in India, we are having very rigorous law. We will discuss in the later part this particular aspect. Now, I talked about the life cycle assessment. You can see that the typical product life cycle, that we are having natural resources. The mother of all kind of a product is your natural resource. Now, these natural resources, if you see that, if we are talking about the plastic part, natural resources, crude oil. Similarly, whatever you are using, they are coming from the natural resources. They used to extract the raw material. You adopt the proper protocol for the design, packaging, maintenance, etc. But if you are adopting the recycling and of the material and component reuse, then it's a added benefit to your life cycle, and it reduces the cost, it reduces the impact, it reduces the burden on the incineration or the landfilling. To explain in a more synchronized manner, this is again I am putting forward that if you are having some electronic item with you, and if you are after recycling, if you are putting in a landfilling operation, it may create either the processing may create the air pollution, and sometimes it may lead to the groundwater. It may create the problem, either the problem through your vegetation, or it may create a problem through like this, whatever you are consuming through your vegetables, etc., because it may become the part and parcel of your agricultural production, and then it may create a problem to your body system. It may cause different other things. Apart from this, you are directly exposing yourself to the air pollution, so it creates a lot of problem. Now, we talk about that we are having the synchronized technology with us, but we are reluctant to adopt it. Now, here a small comparison that why we are not meeting the standards, why we are adopting all such kind of practices. The reason is that we are having two sectors: unorganized sector and organized one. A brief glimpse that we have already discussed in different photographs. And organized sector, why they are not popular? Because they need to put a lot of money. Like if you wish to maintain the smelting unit at the proper synchronized melting unit, then you need to keep this temperature, you need to go for some scrubbing unit, don't need to go for, so you need to put a lot of effort. Whereas in unorganized sectors, there is no such botheration. So economical feasibility. Another very smart thing is that in unorganized sector, there is no safety precaution. They are informal recycles. They need to pay only 200 to 300 rupees per day. Like 100 and 150 rupees. When we investigated with the people working Moradabad site, then they are just paid off rupees 100 to 150 rupees. Whereas if you see in the organized sector, you need to provide them a protective equipments like glove, masks, shoes, and apart from this, you have to pay minimum wages to them. And you know that government is having a policy of skilled, unskilled, semi-skilled, and you can't give less than that particular minimum wages. Another thing is that a minimum in organized sector, the minimum capital investment required. Here you can see when we investigated with one of the organized sector people, they told that the investment of a particular dismantler is about 30 lakh. For a recycling plant, about you need to invest 25 crore, whereas a small workplace and a small amount of equipments are needed for these unorganized sector. Right, so this is the way why this organized sector is not popular in our day-to-day life. I'm not giving the detail impetus because already we have a certain you can say the logistics for the collection of all these things, like rag pickers to kabadi wala to big kabadi wala, and then dismantlers, etc. So we are having a proper unorganized logistics for the collection of those electronic items. I'm saying that's unorganized. They don't know that what is the gravity of those ingredients of electronic items. This is again this one is more appropriate, that this is the trade cycle of your electronic waste items. Although as a consumer we are having only two types of consumers, domestic and official. So when we discard those electronic item, we used to give it either to the relative or to donate it to the institutes, and later on they either exchange with the vendor for higher configuration, and there is one vendor lobby. If we are having some, you can say, the official things in place, then either we used to donate the institutions, like in IIT we used to donate several computers, old computers, to Nagar Nigam schools, etc., or we auction to the vendors. Ultimately it goes to the vendor lobby. They are involved in two approaches. One is they are having a tie-up with the scrap dealers for dismantling, etc. Those dismantlers, etc., they again resend it to the either importers or manufacturers, and sometimes there is vendor lobby, they upgrade to resale for the domestic person. I gave you an example that although government of India rejected the plea of Apple, but the thing is that they collected the exchange old iPhone, and it created a lot of problems in United States. So they approached government of India to install one recycling unit at Chennai, where their modus operandi was that they upgrade for the resale of those electronic items. By this way, they defer the creation of those electronic waste, and then the catchy thing was that they offered Indian people to get the iPhone at a reduced cost. Now, from vendor lobby, it goes to the scrap dealer, dismantler, and then in a synchronized manner with the metal extractor, plastic extractor, then electronic item extractor, and ultimately it goes to this one. So this is the typical trade cycle. Now, catch is that here, where you are having unorganized sector and organized sector, right? Another thing is that this is the waste flow, which in a couple of slides before we have discussed that we are having retailers, we are having kabadi walas, sometimes vendor lobby, manufacturing waste. There are so many things. So it's a very, you can say, the trade cycle, recycler, recovered industries, etc. So this is the proper flow from consumer to the collection to the metal or material recovery to the disposal sites. Now, I talked about the socio-economic factor. Now, one thing is that if you compare with your organized sector and unorganized sector, the reason is there is a certain gray market. Now, if you adopt the organized one, then definitely you are under the umbrella of different tax regimes, etc. But if you are under the organized sector, unorganized sectors, then you need not to bother about those economically unprivileged groups. You need not to bother about the different labor forces, etc. So these are the certain things which regulatory bodies should look into. Now, these the environmental and labor laws, they are peripheral and unimplemented. I told you that these laws are in place, but the problem is that the enforcement of those laws is very weak. The economics of those backyard recycling units themselves are so complex. You can see in the previous figure that it's so complex that still various scientists, various government officials, they are unable to understand that what is going on inside those hidden chambers. Now, again, one more object is that different buyers to buy the different items, both local as well as from other part of the country. When we talk about, when we talk to one of the owner of electronic waste recycling unit, still they involve themselves in a physical aspect. Physical means extracting the metal parts, extracting the other valuable parts in a physical manner. They are not involved themselves in the chemical treatment, because they are facing difficulty to find the buyers for the different items, whereas this particular aspect is not true for unorganized sector, because they are having so versatile. And that's why in Indian context we used to say that our country sustained because of the jugaad technology. So recycling of electronic waste offers several things into attraction. One is that asset recovery. If you are performing the reuse, recycling aspect, then definitely you are recovering the precious metals, you are recovering the precious valuable items. Then thereby you are reducing the impact on landfills. You are reducing the junks and clutters, whatever being created in due course of time. You are promoting the resale and reuse, and above all, you are creating the jobs. See, if you recall the different dots in the circular, if there is a large chunk of people involved in the logistic support of those electronic item, maybe in the collection, maybe the dismantling, maybe the different aspect, different stages of those electronic electronic life cycle. Again, the government organizations, they are giving more and more impetus to reuse. Usually it's an eco-friendly approaches. The basic thrust is that use after repair or modification, and we must promote the second-hand use. That means you extract each and everything of that particular electronic item. But again, it creates a problem. And whatever left in between, that you should dispose with a proper protocol. So in other words, we can say that we must have two approaches we have already discussed. One is upstream, another one is a downstream. So upstream, that means manufacturer, trade, consumers. Sometimes people say that it's a neutral one. And then this is the downstream. So you see that we should maximize this repairing aspect. We should maximize the repairing aspect. We should maximize the recover, and we should minimize the disposal aspect. Only then we can sustain. Now this is again very important point. Why I'm saying this is a very important point? Because during last couple of slides or entire presentation, you see that we analyze the problem, we do have the gravity, we do have the proper methodology. Then why we are not adopting, why we are putting our life into danger? There are 5 broad parameters which need to be considered while designing or characterizing any kind of waste electronic management system. First one is the legal regulation. Now, question is that how elaborate is the legislation? See, I gave you an example during my presentation that in our graduation days, we were encountered with the second-hand photocopying machines. But nowadays, we are not following. So, see, the hidden part of that particular statement was that almost 25 years ago or 20 years ago, the developed country, they did have the policy of their electronic waste management. That's why they were exporting those used electronic items to developing countries. In India, since it is a developing country, we didn't have any such kind of a policy. And thereafter in 2000, 2002, 2003, we adopted the legislation proper, which put an embargo over the transboundary movement of these electronic items. So the question is that how elaborate is? You will appreciate that during our discussion, during my presentation, you'll find that there are certain lacunae in our legislation. That's why we are facing such type of a problem either in Delhi or in Muradabad. Second question is that how much detail does it specify for the operational management of the system? In 2 slides, I gave you an example that the comparative study of unorganized sector and organized sector. Now, second aspect is that system coverage. It's a very, you can say, very debatable term that one aspect of the coverage of the system is whether it is collective, all-inclusive of any brand, or it is a brand specific, or each brand owner is individually accountable. you may put two questions in your mind. One is that suppose in other term is that we are having the system in which all kinds of mobile phone, all brands of mobile phone can be treated. Second is that whether my system is brand specific. Say I am having the Apple phone or a Samsung phone or a Sony phone, then the Sony is responsible for the treatment of those mobile phones. Samsung is responsible for the treatment of their own mobile phone, and Apple is responsible for the treatment of their own mobile phone, their mobile phone. So both the system are having a different lacuna. The reason is that suppose let us take that example of brand owner. Suppose Sony is responsible for the treatment of their own mobile phone. One thing, two things in the picture. One is that Sony is having the IPR value of that mobile phone, patent value. Then definitely they will not share this thing to the other one. It covers with the all inclusive of any brand. Now, second negative factor is that if at any point of time Sony seizes the manufacturing of their mobile phone, then who will be held responsible for the treatment of their mobile phone? It is the problem. Like if you recall that 4 or 5 years back, Nokia stopped the production of mobile phone. In that case, who will responsible for the treatment of those mobile phone? So both the system is both the systems are having lacuna. Lacuna is that why the Sony or Samsung will share its knowledge that, say, suppose I am having this particular mobile phone with me. Apple may use certain proprietary item for the fabrication of their PCB, fabrication of their body, etc. Then if we go for all inclusive of any brand, then definitely we need to share, or Apple need to share the the information about the ingredient. And sometimes it may not be feasible for Apple to share that particular information because of certain values. So this is again a very, you can say, gloomy picture of system coverage. Then another question is that system financing. System financing says that who pays, how much, and for what. Again, I'm putting forward one example. One example is that, again, go back to your mobile example. Suppose I purchase a mobile phone at 70,000 rupees, and if government body they levied me, say, 10% of the cost of this particular mobile phone towards the treatment of probable electronic waste generation, then I am happily paying all those things. But since, because of the variety of factor as discussed in this platform, I am compelled to discard this mobile phone or exchange this mobile phone, say, after 1 year, then why should I pay for remaining part of this life cycle of this particular mobile phone? Why should I pay? Second thing is that if a person is borrowing it from me, maybe in terms of exchange, maybe in terms of, you can say, the donation, then that person, why he may ask the question that why should I bother for 1 year, which Professor Sinha has already used this particular mobile phone? Then the quantification of this thing is extremely difficult. Another negative part, suppose if I say that Apple will be the responsible for this one, then Apple may raise a question that, gentlemen, we manufactured this phone with a life cycle of, say, 10 years. If you are discarding in 2 years, 3 years, then it's your problem. We are not bothering about this. So this particular question, the system financing, because ultimately when we are going for the synchronization of the electronic waste treatment in an organized manner, then the question of, you cannot overlook the importance of system financing. At these questions, the people will raise these questions that who pays, how much, and for what. Similarly, my maid servant may always ask a question, okay, why should I pay? I'm not using the internet. It's of no use for me. So that's why the system financing is again a very crucial part. So to overcome such kind of issues, the two things into existence. One is that the producer's responsibility. They have fixed, the government is now fixing the producer's responsibility. So it's important to consider how much responsibility the producer should shoulder. This need to be deliberated. At which point, I have already I addressed this issue. How the responsibility is shouldered in practice, because there are maybe certain variety of issues. I gave you two practical example that why Nokia ceased its operation in past. Then why then how the responsibilities will be shouldered in practice. So there are several issues attributed to this one. Then ensuring the compliances, I told you that the laws are in place. In last slides I'll discuss couple of laws which are in force, though we are having those laws, but the compliance of those laws is extremely difficult. This need to be such that there are various checks and balances, especially we are having certain free riders in our system. So penalties, although it is there, but for the non-compliances and targets, so for collection, etc., they must be imposed by the regulatory bodies, by the government organizations, etc. So nowadays, the government, all the government organizations, they are working on this extended producer responsibilities. This is the traditional environmental responsibility that producers, distributors had in past, that is safety of the production, prevention, treatment, emissions. They should shoulder the responsibility of the treatment, that is the post consumer stage. They must require the continuing accountability on the producers. Producers must be financially, physically, or legally responsible for their products. We have already discussed, because they know that what is inside. So if they are having the good time, then they always claim that they are having the IPR value. Probably some of you are aware about a legal suit filed in United States courts between Apple Incorporation and a Samsung. And although Samsung won, but ultimately it creates a lot of bitterness among all the community. So there are several integral components of these EPR. They must have a product take-back program. Although some companies are following this, the producer should own the responsibility of the product when it is discarded. Because once they adopt this product take-back program, they can remanufacture it, they may redesign it, etc. The potential benefit of this EPR is that we can go for efficient use of whatever resources available. Because the corporate sector or synchronized methodology is adopted, so we may have a cleaner products and a technology. We can efficient reduction in the manufacturing, because sometimes redesigning, like in the previous slide, remanufacturing intent to go for low inventory, etc. Sometimes, I mean, although it is banned, but sometimes if they ban these hazardous substances in-house, then they can have the environment of less heavy metal, less harmful plastic by adopting this increased recycling techniques. See, we discussed about different legal approaches. Now, these e-waste management, they suffer from different drawbacks. Thus, because of inadequate, improper, inefficient legislation, lack of fund, already discussed while we were discussing about the unorganized sector and an organized one. Poor awareness. See, we are the learned people. Even we are not aware about this particular approach. The awareness that how much my mobile, how much my laptop is efficient. We don't have any idea. Even if it is not useful, and I am having some money in my project, I'll always intend to buy a newer version of my laptop. reluctance on part of a government and the corporates to address this particular critical issue. Remember, this is the critical issue as on date. It will become more and more severe in future. I'll give you a brief glimpse about that. What are the legislations we do have? First, this particular approach was covered under the Hazardous Waste Amendment Rule in 2003. Then exim policy, etc. The government adopted in 2002 to 2007, where they banned the second-hand computer, laptops, etc. And other international responses with respect to the United States, European Union, they do have all the policies in place, Japan, Netherlands, etc. And the EPR, which we discussed, is based on this RITA, that is Recycle IT, that is developed in Austria. This is an initiative to collect the used computer from manufacturers and other company, upgrade, repair the computers and sell them at a reasonable price. So the base of the EPR policy, based on your this electronic waste proper management policy, is based on this RITA. The crust of this particular legislation is the Basel ban. It calls the prohibiting the export of hazardous waste from developed to developing countries. And in 2003, the government utilized this particular approach because they proved that all these electronic gadgets, they do have this type of hazardous substance embedded. Recently in 2016, Government of India, they adopted and they implemented this e-waste management rule 2016. This applies to every manufacturer, producer, consumer, bulk consumer, everywhere. I mean, if you are discarding your mobile phone in unsynchronized manner, even government may impose penalty to you. So by this law, the government fixed the responsibilities of the manufacturer, that they will collect the waste during manufacture, seek authorization for the treatment of those waste. They maintain the record and file returns for all kind of these EPRs. The producers, they will go for channelization of collection protocol, EPR authorization. They deposit certain refund scheme. Now this DRS is again a small thing which I would like to discuss. That suppose they are levying a certain quantity of money to charging money to you regarding this disposal protocol. Then when you discard those items and return it to your manufacturer or producer, then they will refund you certain amount of money, although it is in place, but people are a bit reluctant to claim all those things. Then this covers the logistic support of e-waste collection, storage of e-waste collection. They set different type of protocol for creation of all these things, and that's why when I say that 148 industries are involved themselves in such kind of a practice, then they are covered under the umbrella of these two things, that is collection of e-waste and storage of e-waste. So in you can say the concluding remarks, we must adopt the fourfold responsibility. We should promote the proper or synchronized collection of those electronic waste items. Go for this assessment of end of life electrical and electronic gadgets. We must go for individually or collectively, that is to provide the contact details on helplines of the collection centers, although 99% people, they don't aware about this thing. We must create the mass awareness as far as it's a responsibility of our scientific community, that what are the information about the hazardous substance and information on the website and booklets. Trust me, We never bother to inquire about various kind of hazardous substance in the electronic gadgets. We are always looking for the radiation level. We are always looking for the lithium battery aspects, etc. Government should promote the establishing and financial clean channels by to the dismantlers, recyclers, arrangements, financial arrangements, and establishment for the clean channels, etc. Remember, when we adopt for the proper e-waste disposal policy, then definitely we may say that it's a one man's junk. For us, it's a junk, but for other man who is involved in the treatment, who is involved in the recycling, who is involved in the reusing, who is involved in the logistic support, it's a treasure for them. And that's why people are coming up nowadays for creating this type of support. Now, what lies ahead? This is a cheap source of raw material, that is every e-waste, because for us it's a useless thing. There are those advocating the recycling e-waste while stressing the need for the safe recycling, setting up more plants. When we are estimating the 52 lakh ton of in 2020, one part of the future doesn't look too bright, but other part is bright, because it is this 52 lakh ton is a raw material for future products. So take the things in a positive manner. Now, I told you that these 148 units are channelizing, and they are keeping an eye over this particular approach, that 52 lakh ton, which is the e-waste is generating, that is the raw material. So that means they are looking their future of business in that particular debris. So you create more e-waste, it will be a wealth creating approach for them. So at last, in the concluding remark, as far as e-waste is in question, it emerges one of the fastest growing waste stream worldwide today. And there are so many accelerators like COVID-19. Electronic equipment is one of the largest known source of heavy metal without effective collection, reuse, recycling system. They will be dangerous to the environment. Reuse and recycling of electronic equipment is a beneficial alternative than disposal. So those who are teaching somewhere, they may give small projects to their students, so that they can grab the idea how to reuse, recycle all those things. Product design by using safe and environment-friendly raw material in most emerging technology, because whatever you are using in your mobile phone, it's not biodegradable. Must create the awareness among the people, and above all, we should honor whatever legislations being laid down by our government bodies, and we should implement, so that we help our environment to keep it away from electronic waste from growing. Thank you very much, and I'll be happy to answer any query if you are having.
Thank you very much, Dr. Sinha, for this valuable talk on a very important topic, which is the need of the day, and that really needs a very critical thinking, discussion, and implementation. Implementation, I guess, is the most important part here, because we have been discussing this, we have been thinking about this for a little longer now, but implementation is lacking somewhere. Really, thank you so much for your valuable, thoughts and detailed thoughts on this particular topic. So there were few questions during the beginning of your talk, but I think you have already answered all the questions in detail in your talk. There is one question that is there any statistics about recycling in India?
See, I gave you one small statistical figure, and that is 148 units. See, still we don't have any proper logistic, or we don't have any proper protocol for the collection of all those electronic items, and the segregation classification is again the weakest part of our protocol. So clear cut segregation, clear cut statistical data is as on date is very difficult. Even the different agencies like IRG, etc., they are struggling to find out. See, I gave you an example that from IIT Roorkee, almost 20 kilometers away from this place, there is one unit called Atero. They are even not having the data, and they are just relying upon the sources that whatever they are getting, either the laptop screen or a computer, etc. So as on date we don't have any, and that's why this particular part was discussed by me in the issues and challenges, if you recall, that we don't have any proper protocol for collection of these things. Remember, we do have another variable or another vertical to this particular problem is that we do have the data that how many computers, we do have a data that how many mobile phones are being sold by the different vendors. But the problem is that because the variety, because we are not having synchronized disposal system. See, I told you that I'm having the mobile phone and just give it under the exchange scheme to my vendor, then we never bother, and again it starts its new life. Suppose one rickshawala, it purchases a mobile at a throwaway price. For them it's a useful thing, but for me it's a useless thing.
Yeah.
So this type of statistical information gathering system is extremely poor in our Indian context, and that's why it is covered
That's
under the head of.
Okay, great. So that's very good. Actually, this exchange policy or exchange offers that
Yes.
have been now, offered by the vendors, and that has really, solved many of the purposes, basically, including reusing and also saving some money and etc. So I just have one question. So
Right.
when we talk about, these e-waste management rules in India, of course, these are rules, so these should be followed. However, there is no record of like how many mobile phones I have or how many computers I have. So I'm not taking, if I'm not responsible to recycle them properly, then those rules possibly are lacking somewhere. So
Right.
is there a possibility to link my electronic gadgets with my, let's say, some KYC document, for example, my Aadhaar card or something like that, so that there is a proper record of electronic gadgets that I am owning, and so I am also taking the responsibility that when they are of no use to me, I properly give them back to the vendor so that they are properly recycled. So is there a possibility of
Yeah,
doing
it
this?
is. Government, see, government is working on it in a hidden way. You can see that 2 years or 3 years back, government was, I mean, in the process to link all your mobile connections with the Aadhaar card, right? But later on
Okay, great.
there was some relaxation, and if you see that, if you today if you go to the market and if you're willing to buy a new connection, then definitely you need to produce Aadhaar card. So in a hidden way, government is capturing the data. But for laptop, refrigeration units, refrigerators, etc., it's still they are working that how you can link. And trust me, on a lighter note, then when you connect all your devices under IoT, then they will have an eye over your system that
Yeah, right.
they're right. So see,
That's true.
see, we are delivering this lecture to your STC, then definitely somebody is keeping an eye over you, that we are utilizing this bandwidth, we are utilizing this and that. So
That's true, that's
probably in couple of years or in the next decade, we can see this type of approach, and government will capture your neck.
Yeah,
But
okay.
right now,
That is actually required. Yeah,
that is
I think
required.
that's required for especially for a country which has second highest population in the world.
Right, right,
We have to somewhere be strict on these.
right.
So there are a couple of more questions if you allow me to read
Yeah,
for
sure,
you.
sure, sure. Absolutely,
Uh,
absolutely.
in one of the slides, you mentioned that 80% of e-waste is transported from USA to India, China, etc.
Yes.
I wish to know in which form it is coming. I mean, to India.
See, there are two approaches. Either you have a completely knockdown units like Apple or etc. I gave you another example that Apple was having a large inventory of their used mobile phone, and then they offered government of India to establish one unit at Chennai where they can refurbish, rebrand it, and they offered that the Indian people will get the Apple mobile phone at a cheaper price. One approach was this one, and second was that I mean previously the US and China both were the hub of electronic items. If you take the autopsy of your mobile phone, you will find that there are only two countries, those who are involved in the manufacturing of all the hidden items of this, either China or United States, sometimes Korea. So you cannot overlook the importance of these these approaches.
Hello, sir. Good evening. Good afternoon.
Good afternoon, sir. Good afternoon.
Thank you so much for the nice talk.
Thanks, sir.
Thank you very much to be with us. Yeah, that talk was excellent.
And thanks, Professor, for giving me the
management.
opportunity. Right. Okay, sir.
So once again, thank you very much, sir. Dr. Rakesh, I think his network is not working.
No problem, sir. No problem.
Yeah, that's why he asked me to conclude. No problem. I will conclude. So thank you once again very much on
Thanks,
behalf of
sir.
Department of Chemistry and organizers. We are highly thankful to you, sir.
Thanks.
Excellent talk, and I'm sure most of our participants they are benefited out of your talk, and highly informative talk, sir. Thank you so much, sir.
Okay, sir. Okay, sir. Thanks.
Again,
Thanks for giving me.
your tea is due.
Oh, sure, sure.
Tea is due.
Okay, okay, sir. Okay, sir.
Yeah.
Okay, okay. Thank you, sir. I'm disconnecting.
Okay, okay, sir. Thank you. Namaskar, sir.
Namaskar.
Namaskar,
Namaskar,
sir. Namaskar. 2 o'clock. Hello, participants. The next session is at 2 o'clock. Sharp at 2, please. Be at 2. Thank you once again. Good day, all. And may I see you at 2.
So, how is NIT Jalandhar?
NIT Jalandhar is also working non-stop.
Okay.
Yeah, non-stop. Yeah, students are, all the students are not coming. I mean, few students are coming.
Okay.
But yeah, things have, started working kind of normal
Okay.
after 3-4 months.
So, you are in the office?
Yeah, I'm in the office. Unfortunately, my system stopped working,
Okay.
just a few minutes back.
Oh, okay.
So I'm using my colleague's system,
Okay, okay.
Dr. Sadika, who is also
Okay.
the coordinator of the short-term course.
Yes, yes.
Yeah, she worked with Dr. Mandal, Dr. Sanjay Mandal at.
Oh, okay, okay.
So,
Postdoc or PhD?
no, she did her PhD there.
PhD. Okay. So, nice.
So have you moved to your new campus or you're still in the?
Currently progress. We are
okay.
shifting actually.
Okay.
It will take this end of till this month.
Yeah, certainly.
Yeah.
Yes, of course. Okay, so maybe I think we can start.
No problem.
So welcome, ladies and gentlemen, again for this new session. of the short-term course application chemistry for engineering applications. So our speaker for this session is Dr. Jalandhar Govindaswamy. He's an associate professor at Institute of Nanoscience and Technology, Mohali. To brief you about Dr. Govindaswamy, he obtained his MSc in organic chemistry in 2003 from University of Madras, and then a PhD degree from Department of Organic Chemistry, Indian Institute of Science, Bangalore. And after that, he worked for a few months at IST Bangalore with Professor N. Jayaramnan as a research associate. And then he moved to ETH Zurich, which is also known as Swiss Federal Institute of Technology, as a postdoctoral fellow, where he worked with Professor Francis Dietrich. He's a pioneer in supramolecular chemistry. And there he worked from January 2010 to December 2012. And then he moved to University of Cambridge as a postdoctoral research associate, where he worked from January 2013 to May 2015. And then he joined as assistant professor at INST Mohali in 2015, and as an assistant professor. And recently in 2019, he was promoted to the position of associate professor at the same institute. So Dr. Govindaswamy has received a few prestigious awards. He was awarded with Ramanujan Fellowship by DST SERB for 5 years, and then he also received Early Career Research Award by SERB. He has also received 2.5 years postdoctoral fellowship sponsored by EPSRC, which is United Kingdom's main agency for funding research, and he worked at University of Cambridge using that fellowship. And then he also had 3 years postdoctoral fellowship that was sponsored by European Research Council at ETH Zurich. So Dr. Govindaswamy is currently monitoring 5 research scholars who are working in different niche areas. A few of them are donor acceptor compounds for optoelectronic sensing and high energy related applications. He also works on framework materials for applications in energy storage, catalysis, biosensing, and photovoltaics, and also functional nanomaterials as smart vehicles for drug or antibody or gene delivery applications. Recently, 2 technologies have been developed at Dr. Govindaswamy's laboratory. One of those is low-cost method for producing antileptic drug rufinamide, and another technology is kit for fluoride ion detection and quantification in drinking water with naked eye. Not further taking more time, I would like to invite and welcome Dr. Govindaswamy for his presentation. Thank you.
Thank you, Dr. Rakesh Kumar, for this kind introduction. Am I audible actually?
Yes, you are audible. Your slides are also very visible. Quite.
Okay, thank you. So first of all, I would like to thank the organizers who is organizing this workshop for chemistry for engineering applications. So I would like to thank the organizers, including Dr. Sadika Kullar and Dr. Rakesh Kumar, for inviting me to give talk in this interesting workshop. This particular workshop I felt very interesting and unique. This is the first time I read the title Chemistry for Engineering Applications. It's indeed very relevant, the title, the kind of work I'm pursuing here. So in this regard, I'm really happy to be here. So as you can see, the title of my talk is Functional Organic Nanomaterials for Sensing and Catalytic Applications. So before starting my talk, I would like to mention about Teachers' Day. Recently we celebrated on September 5th. So my group, we were celebrating Teachers' Day. So this talk I would like to dedicate to my teachers, supervisors, and former supervisors of doing my graduation as well as postdoctoral time. Professor N. Jaraman from IIC Bangalore, and Professor Francois Dietrich from ETH Zurich, and Professor Jonathan Nishke from University of Cambridge. So without them, I will not be here. In this regard, I would like to thank them. Now, those participants from outside Punjab, this slide I would like to show you. So where we are from Chandigarh. Actually, we are from Mohali. It's a border of Chandigarh. Mohali belongs to Punjab, whereas Chandigarh is a Union territory. Chandigarh is 275 kilometers away from Delhi. So it belongs to North India, as you can see. So where our institute is, as I said, it's very adjacent to ISER Mohali. Everyone might be knowing about ISER. So it's we share border with ISER Mohali actually here. This is our proposed plan of building plan or the campus plan, Institute of Nanoscience and Technology. So currently the actual scenario is like this. So this is the actual building now exists. So where the red spot, there my office will be located. So this institute is kind of unique as compared to other institute because this is the one and only institute dedicated solely for nanoscience and nanotechnology. Though nanoscience and nanotechnology centers are there in almost every university and institutes, but the whole institute dedicated for nanosciences, this is the only institute. In this regard, I'm really happy to be working in this institute. So this institute directly supported by Department of Science and Technology, Autonomous Institute. So our institute have so far working with in the transit campus. Our transit campus have several laboratories located in different institutions around our campus within the radius of 12 kilometers. Initially, it was in PU. We had some lab that has been shifted to CIAB, Central Institute for Advanced Bioprocessing Institute, and the NABI, National Agri Bio Institute. Also in ISER, we have a shared lab. So far, last 5 years, we have been working in these different labs, running around these labs. So luckily, soon we are currently shifting from all these labs into our main campus. We are under that process now. Now moving to our work. So this is my overall research experience slide. So if you can see in this slide, during my PhD in IISc, I worked on dendritic polymers. Dendritic polymers have shown to be application in several different areas. Sorry, excuse me. I just switch off my phone. Yes. So this is my PhD time, and then moving to my first postdoc, ETH Zurich, push-pull chromophore, where I worked on small molecule aromatic-based compounds, where these compounds found applications in optoelectronic applications mainly. And then moving to University of Cambridge, I worked on macromolecules using metal organic cages or covalent organic framework type material. So as you can see, the kind of material I handled, polymeric to small molecule to macromolecule. So this gave me a freedom of working in any kind of molecule synthesis I can handle easily. So these are my core competence: synthetic organic chemistry, polymer chemistry, metal organic chemistry, small molecule synthesis, supramolecular chemistry, optoelectronic materials, etc. And recently, after joining Nanoscience and Nanotechnology Institute, I gained new experience of nanoscience and nanotechnology as well. So by put together all these areas, I would like to call them as one single phrase, that is functional organic nanomaterials. So as you can see in my current research area, functional organic materials laboratory, where we focus mainly on 3 different areas. One is majorly catalysis, the other area is push-pull chromophores, and the third one is customized polymeric nanoformulation. So today I will be presenting mostly on catalysis and push-pull chromophore. as opposed to this polymeric nanoformulation that is more towards biology, whereas this catalysis and push chromophore more towards material aspects or devices aspect. So by considering the title of the workshop, Chemistry for Engineering, I would like to focus on these two areas. So depending on the time, I would like to first cover the push chromophore. If I have time, I will cover a little bit about catalysis as well. So this is the slide I'm sharing you as a conclusion from the beginning. The conclusion slide is that the nanoscience is a central science for coexist between any disciplinary, say chemistry, physics or biology. Also, nanotechnology or engineering, this always combined with the interdisciplinary research. So if you want to bring up any particular device or application, one has to work with interdisciplinary research. Without it, I don't think you can achieve any meaningful applications. So that is why the fundamental research, which should be applied for the translational research. So in this regard, I would like to give you a brief introduction about chromophores, colors, because this modern era is filled with electronic devices, right? So any electronic devices, if you go through, the major active ingredient is donor and acceptor system. Without donor and acceptor system, it will be difficult to imagine any current devices. For example, you take it rectifier, you take it organic light emitting diode, you take it photovoltaics, all works based on the principles of donor and acceptor, whether they are conductor or semiconductor. So the semiconducting nature comes from donor acceptor systems. And that system, how they affect upon interacting with the radiation, that makes it the most of the electronic devices working principle. So in this regard, I would like to give you a brief introduction about color chemistry, why color chemistry is important in coming to engineering application as well, such as electronic devices. So what is color? Color is when the light either reflected or transmitted or emitted from far, how that light interacts with our eyes. So the visual sensation, depending on the wavelength of the rays or light, producing different varying colors. So that color chemistry is called, color chemistry is a subject, and that subject is mainly dependent on these parameters. For example, whether the light excites the molecule or the molecule transition metal if it is transition metal compounds, they involve d orbitals. If it is organic compounds, their color is due to electronic transition, or how that electronic transition is delocalized among the system. For example, in aromatic, the pi bonds are delocalized. That produces electronic transition, or how they affect the electronic transition. So in 1876, this theory, or chromophore oxochrome theory, where he proposed that any pi bond system, unsaturated system, should be called as chromophore, and then any particular functional group having either electron donor or electron withdrawing group can alter that chromophore property. That is called oxochrome. So, for example, in this system, chromophore is this azobenzene, whereas oxochrome is the amine functional group. Now, why this chromophore concept? It's very much exists in nature. So if you look in the outside, if you go out and see, look around, everywhere green color. That green from the plants, leaves, are dependent due to the presence of chlorophyll pigment. The chlorophyll pigment magnesium porphyrin system is the chromophore, actually, whereas the oxochrome is the substituent around it. For example, vinyl group, methyl group, ester group. These are the oxochrome system, whereas the methyl magnesium porphyrin is the chromophore, and this is largely abundant on the earth. Similarly, if you come to vegetable carrot, where you can see strong orange color, that is due to carotenoid, almost everyone knows. And similarly, if you go to retinal, how we visualize, the visualizing mechanism is due to the chemical called retinal. the 11, whether it is on the 11 position, whether it is cis or trans, and that cis to trans transition mediated by light is the mechanism behind the visual sensation. And similarly, if you go to another eating product, that is curcumin, which is strong yellow color, that is also due to the curcumin chemical in turmeric. So all these are a very common property or material we see around us, which are dominated by the pigments or the chromophores. Now, how that chromophore can be varied, their properties, by changing whether the absorption of the light, whether it is shorter or longer, it can be varied very much by depending on the chain length. For example, if you take this is the chromophore where you have 4 or 5 conjugated double bonds. When you increase from 5 to 7 or 5 to 3, the absorption of the light can be varied, whether to red shifted or blue shifted. If it is extended, it's red shifted. If it is lower, then it's blue shifted. So this is one of the approach based on length of conjugation. The other approach is to varying the substituent effect, that is basically oxochrome property. In oxochrome property, in this system, if you can see, this amine is having lone pair, which is considered as electron donor, whereas the nitro group having cation, that is electron withdrawing group. So when the lone pair electron donating group can give electron to the electron withdrawing group via the pi conjugation spacer, that is phenyl group. This system is called push-pull system. This to see that how much one can change the light property, absorption property. You can see in this UV visual spectrum that for the aniline, in case of aniline, where only electron donor is there, that can be treated as a push system, whereas the nitrobenzene can be treated as a pull system, that is only electron withdrawing group. And you can see in both cases, you see very short absorption wavelength, around 250 to 300 nanometer. Whereas when you conjugate both amine and nitro in one system, that is push-pull system, then you can see a very long absorption charge transfer band around 350 nanometer. And not only this conjugation charge transfer can be greatly altered based on the position also. For example, restriction in the resonance, that is limiting resonance of conjugation. For example, whether it is substituted with the para position or meta position. In case of meta position, this charge transfer is completely almost negligible. So this indicates that any one molecule light absorption property can be greatly varied depending on whether you want longer absorption or shorter absorption by changing the substituent effect, as well as the resonance conjugation effect that can be controlled through either para or meta position or changing the length of the conjugation. Now, if you consider again the chlorophyll, it is another example where you can greatly alter the light absorption property based on the electron donating and withdrawing group. So in case of chlorophyll, again the magnesium parpyrene chlorophyll, if the R group is methyl, that is called chlorophyll A. Chlorophyll A absorbs around the green absorption, which is around close to 700 nanometer, whereas the R is equal to electron withdrawing group aldehyde, then the light absorption property is blue shifted to here around 620 nanometer. So this simple variation in the methyl to aldehyde can greatly alter the absorption of the light. So this indicates that one can play with this molecule to achieve greater light absorbing or light emitting property, which can be used for various electronic applications where the engineers can play around. So this is one particular table. As you can see, what are the tools available in organic chemistry? In organic chemistry, these are the functional groups, varying considered as acceptor functional groups, and this column considered as a donor functional groups. And if you look at the sigma Ahmed constant parameter for nitro is the highest electron withdrawing nature, which is showing 0.78, whereas electron donating group, highest electron donating group is NN dialkyl amine, which is showing minus 0.83 value. So when you go from top to down, the strength of the electron donor goes down. Similarly, electron withdrawing acceptor character goes down. So why do we care this, whether the donor or acceptor? Why do we care? As I mentioned earlier, that these days the world is full of electronic devices. It is hard to imagine anybody now without electronic devices. For example, mobile phone. Now everyone almost having in their hand mobile phone. Mobile phone is can be considered as a computer nowadays. Whatever the computer can do, the mobile can do. That miniaturization of computer from big 1980s desktop monitor to the handheld phone computer is possible due to the molecular chemistry actually. So in the initial days 1980s, all those devices controlled by our work based on silicon materials. So silicon is a inorganic silicon material is the semiconductor material is the based on bulk property. So when your devices works with the bulk material, then the size of the instrument or the devices is very huge. Whereas when you go the same property, if you can achieve through single molecular level like this porphyrin, then the device can be greatly minimized. So that is the new area called organic electronics. That is called our molecular electronics. So in 1974, Aviram and Ratner proposed a nice concept for the first time that similar to PN junction diode based on semiconductor material, silicon-based semiconductor material, one can also make devices based on organic molecule, wherein using the chemistry of functional groups of organic donor and organic acceptor molecule, one can make a similar PN junction diode. So as you can see in this diode molecule, where tetrathiophulvalene is the donor molecule, strong donor, whereas tetracenoquinodiamethane is the strong acceptor moiety. When these two strong donor and acceptor moiety interlinked by the spacer is the electron insulator actually, meaning there is no conjugation can happen because of the aliphatic nature, no unsaturated bonds presence here, that makes it is an insulator molecule. So when you separate this strong donor and the strong acceptor through this insulator molecule through rigid spacer, this can act as a PN junction diode. That was the original proposed molecule, and this has created a huge huge scientists have been started working on this kind of area to produce organic molecule based electronic devices. So as you can see, whether it is donor or acceptor, that controls the electronic devices property. So for example, how you can control the electron richness or electron poorness of the molecule. So that is based on HOMO-LUMO of any particular molecule. Suppose if you take a donor molecule having HOMO and LUMO, wherein the donor is usually HOMO-LUMO level is higher, whereas acceptor HOMO level is lower. So when you mix up these two donor and acceptor together, what happens? The product, which is charge transfer material, will have a lower HOMO-LUMO band gap than the starting initial materials. So these two HOMO-LUMO gap is much longer than this HOMO-LUMO gap. So this is called charge transfer chromophores or charge transfer molecules. So they are usually lower band gap than the initial either separately donor or acceptor molecule. So this property is a very much advantage to produce any active materials for electronic devices, for example, photovoltaics. Okay, so here I'm happy to show you or mention that during my postdoc work, we have synthesized the first time very closely resemble to original aviram type rectifier molecule. So wherein we have strong donor TT tetrathiophylvalene and TCNQ derivative strong acceptor, which are linked by rigid organic spacer. So this was the first paper synthesized showing all three requirements, that is strong donor, strong acceptor and rigid spacer insulator. Whereas people have before attempt various molecules have been synthesized, having any one feature is lacking. So this molecule after synthesis, we verified that the original Abraham Ratner proposed concept indeed works. But however, today I'm not going to discuss on this work. Now, today what I'm going to discuss mostly is the chemistry called 2+2 cycloaddition retro-electrocyclization reaction. So what is 2+2 cycloaddition retro-electrocyclization reaction? This chemistry is also called as a click type reaction. You know what is click type reaction? I'm sure most of you know about Sharpless copper-based, copper-catalyzed azide alkyne cycloaddition reaction, which is 1,3-cyclopolar dichloroaddition. That is called as a click type reaction because in order to call click type reaction, the reaction has to satisfy several criteria. For example, there should not be any side products, atom economic, no extra reagents required, solvent independence, or mostly avoidance of organic solvent, high yielding. These are the major criteria one reaction should satisfy to call as quick type reaction. Similarly, this reaction, the 2+2 cycloaddition followed by retro-electrocyclization reaction yielding tetracyanobutadiene system also can be called as quick reaction, as this reaction satisfy all those criteria. So what kind of reagents or starting material can react with can undergo this reaction to form this product? For one of the major criteria here is the alkyne starting material should be attached with the electron donating group, whereas electron deficient dicyanovinyl group or tetracyanovinyl group should be attached with the electron deficient group, that is cyano. In this case, electron donating group can be aniline or various, these are the electron donating group actually investigated, metal halides, thiophene, ferrozine, aniline, azulene, etc. Whereas electron deficient group can be cyanide or this tetracyanoquinone derivatives. Now, what happens? This electron rich alkyne and electron deficient olefin undergoes 2+2 cycloaddition to form cyclobutene intermediate. This cyclobutene intermediate undergoes thermal retro-electrocyclization reaction to yield butadiene system, 1,3-butadiene system. Now, why do we care about this system, 1,3-butadiene? 1,3-butadiene is kind of very interesting, also very different compared to typical chromophores, where, for example, planar-based chromophore, benzene type chromophore, where those benzene chromophores are usually planar, like pyrene, anthracene, whereas this butadiene is a non-planar system where the single bond is usually having an angle of 36 to 86 degree. That means they are not planar, they are kind of non-planar like this. So why do we care whether they are non-planar? Because this non-planar characteristic brings huge property difference. For example, they are usually highly soluble due to avoidance of stacking nature, and secondly, they are highly charge transfer chromophore because the donor and acceptor functional groups are directly conjugated, and due to this direct conjugation of donor acceptor, they are usually showing efficient intramolecular charge transfer band. That charge transfer band can be easily recognized by their color nature. As you can see here, these are showing very strong different colors. So depending on the number of substitution or nature of substitution, the intents of the color can be varied. Now, how this mechanism works, this is the mechanism you can see. The aniline donor, electron donor, actually migrates to activate this alkyne bond. One of the alkyne bond actually opens up to attack here, and then here the dicyanovinyl anion generated. So here in this case deuterionic intermediate forms. It is an intermediate. This deuterionic intermediate, this anion again cyclizes at this allene bond to produce not allene, ketene form, and bond to produce the cyclobutene intermediate. This cyclobutene undergoes retroelectrosylation to give tetracyanobutydiene system, which is attached with the donor system. So now this aniline blue part is the donor, this red part is the acceptor, and due to this charge transfer from donor to the acceptor, you see the very high longer wavelength absorption bands in the UV visible spectrum. Now, what are the donors and acceptors have been used in this chemistry? As you can see, these are the kind of different donors have been used so far: azepine, BODP, NN-diphenyl, azulene, triazine, carbazole, tetrathiophylvaline, etc. Whereas the acceptors so far used are usually tetracyanoethylene is the major one, and then tetracyanoquinodimethyl, and very rarely tetrafluorotetracyanoquinodimethyl dicyanovinyl have been used. Now these are some of the compounds have been synthesized, selected examples, where in 2005 this molecule is called tetracyanobutydiene. Please keep this in mind. I will be repeating often tetracyanobutydiene in my talk. So this is called monosubstituted tetra-1,3-butadiene. This is called bis-substituted 1,3-butadiene, and here pentacyanobutydiene, etc. Now, I showed you in this slide that these products are very good. They are showing twisted pi system and efficient charge transfer characteristic. Also, mostly reversible redox behavior in this system. However, one particular limitation I have not mentioned here, one or two, that is they are usually non-fluorescent, because their fluorescence is usually quenched by due to the photo-induced electron transfer process from the donor moiety. And secondly, if you look at the nature of the substituent here, you cannot further functionalize these molecules. For example, can you bring an alternative functional group? For example, if you want to attach, say, peptide or protein or dye or DNA, any or fluorescent dye molecule, if you want to attach any of those, it's very difficult to attach using conventional synthetic method. So one is further expansion or further functionalization limited. Second is they are usually non-fluorescent. So to make them fluorescent, what will be the approach? That was when I started working, I have been thinking how we can make them fluorescent, one, and second, how we can make them further functionalization. They should be fluorescent as well as functionalization should be easier. So the hypothesis was that if I need to attach a functional group that is R here, and then to the tetracyanobutydiene moiety, so I was looking for a functional group which can bring easily using conventional synthetic method. So the idea came that that should be urea moiety. In the urea moiety, if one can buy or make various functional group containing isocyanate, and that can be treated with the aniline amine donor here. However, the question is, in order to bring this urea functional group, the urea should be acting as a donor in order to generate tetracyanobutydiene chromophore. As I mentioned in the 2+2 cycloaddition retroelectrosylation chemistry, one of the criteria the reaction should choose is the electron-rich alkyne. So if I have a urea moiety, whether it can act as electron-rich alkyne or not, that was the question. Usually, urea is considered as a electron-withdrawing group. It is not regarded as a electron-donating group. However, we were assuming that if this lone pair should be available for the alkyne as electron richness, then this carbonyl may affect that due to conjugation here. However, if this extra lone pair is present here, that can, when it is participating as a conjugation here, then this lone pair should be available for the electron activation, the reaction activation. So that was the hypothesis that maybe urea can act as electron donating group. And also, in addition to that, due to the intramolecular charge transfer through space effect, in addition to the through bond effect, whether it can also show fluorescence emission property. With this hypothesis, we have tested various isocyanate molecule, mono as well as bis isocyanate, commercially available, and then treated with aniline phenylacetylene substituted with the amine functional group. So upon treating these two reagents, we made urea, several urea attached with the alkyne group. Now this is the critical reaction, whether this alkyne can react with the tetracyanoethylene to undergo 2+2 cyclization retroelectricization reaction to provide tetracyanobutydiene. Indeed, we were happy to see that when we tried, it did work very efficiently. In fact, this reaction was much better than aniline moiety. Usually, so far, the aniline was regarded as the best electron donor in this chemistry. However, we were very pleased to see that this urea also acts as a very good, strong electron donor. So I will come to some limiting factor on this later, but at present we were very happy to isolate this molecule, these chromophores, and prove that they are equally good charge transfer chromophore as compared to the control compound of only aniline instead of urea here. So the compound number 4 is the NN dimethyl instead of urea functional group here. So if you can see 1, 2, 3, they are much stronger color than control compound. As you can see, color compound absorption is green color here, whereas other urea compounds showed higher intensity. Also, in case of emission property, as you can see, the control compound did not show any emission, which is green color, whereas urea chromophore showed strong emission group property. So in addition to this strong emission property, we were very surprised to see that this chromophore showed white light emission. So as I said, it is surprising because white light emission is very rare. I will come to that in a later slide. Before that, I would like to show you I would like to address one particular aspect, that is why urea acts as electron strong donor, and which is conventionally not considered otherwise. For example, that is based on Hammett constant. If you look at the Hammett constant, NN dimethyl is -0.82, whereas methox is -0.27. So everyone knows that methox is much less electron donating group than NN dimethyl. And the Hammett constant, if you compare with the urea, that is similar to methoxy group. That means they are weak electron donor as compared to NN dialkyne. However, if you look at the reactivity in this reaction, so the 2+2 cyclization reaction between electron-rich alkyne with NN dimethyl to tetracyanoethylene to provide this compound, tetracyanobutydiene, in 97% at room temperature in 2 hours is very strong, very good reaction. Whereas in the case of methoxy, the yield is 32%, even at high temperature, 80 degrees Celsius. So that indicates methoxy is a weaker electron donor. However, if you look at the urea, in our case, we get 60% at 0 degrees Celsius, even lower temperature than the NN dialkyne. In 2 hours, we get 60%. So this indicates urea is much more strong electron donating than NN dimethyl. However, the Hammett constant does not show that fact. Usually, in this case of methoxy and NN dimethyl, the Hammett constant linearly works, whereas in case of urea, it doesn't work. So we were thinking what could be the reason. The reason is, so one can never think urea can be regarded as a amine equal to amine. So when we looked into the literature, what could be the reason why urea shows strong electron donating ability? So we always look for the Hammett constant from the book chemistry. Even from bachelor degree book chemistry, I think you guys would have studied about Hammett constant. There is another parameter called field effect or polar effect. Polar effect is the combination of inductive effect, mesomeric effect, and field effects. Usually, Hammett constant is based on mesomeric effect or inductive effect, whereas polar effect is the combination of various effects, inductive mesomeric field effects. As every molecule experiences all these effects, so one has to consider polar effect rather than Hammett constant. Then when we are looking at what is field effect is the result of an electric field produced by charge localization in a molecule. So for example, if you take this halide molecule attached with the carboxylic acid, this CX bond having dipole moment of delta minus here, delta plus, this charge separation here creates a electric field. That electric field affects this pK of this carboxylic acid, as you can see from pK of 5.9 to 5.14 depending on the substituent here, whether it's hydrogen or cyanide or halide. Similarly, here in this molecule, the difference between these two molecules is the CCl bond conformation. The CCl bond conformation in this case is towards the carboxylic acid, whereas in this case opposite to the carboxylic acid. Then the pK of carboxylic acid is greatly affected again in this case. This is also due to the polar field effect actually. So this makes very much reasonable. Then we were looking at then what would be the field effect value for urea. That clearly demonstrates that urea can be regarded as a strong donor to NN-dialkylamine, as the field effect value for NN-dimethyl and urea is almost similar, whereas methoxy is very high. So this indicates that Hammett constant does not play a role in this, whereas the field effect plays a role. So based on this, we propose that in the case of urea, in addition to through bond charge transfer, through space charge transfer also exists due to this generation of electric field induced by this separation of partial delta plus and delta minus in the amide bond here. And then as I mentioned earlier, that white light emission is the very unusual phenomenon observed rarely in few cases. So far, white light emission observed in whatever the molecule can be categorized into two aspects or two approach. One approach is combined emitter approach. You all know that if you mix equal amount of red, green, blue, you will see white light emission. That is called complementary color approach. So similarly, the complementary color of cyan and yellow can produce white light emission. So there are either two color combination or three color combination RGB can produce white light emission. So in order to achieve this white light emission, so far the approach is to take yellow absorbing compound or yellow emitting compound and cyan emitting compound and mix them together to achieve white light emission. So that means that can be either nanocomposite, physical mixing, or through covalent bonding. So one can achieve white light emission. That means one has to know whether this chromophore can emit yellow light, whether this chromophore can emit cyan light, and similarly red, green, blue. The other approach is the single molecule, single chromophoric based white light emission. However, here again, this particular single molecule NDI based one, pyridine amide based molecule, showed yellow color emission, whereas upon formation of nanoparticle self-assembly leads to the formation of cyan emission. Now, when you mix this monomer and nanoparticle self-assembly material in equal proportion, then creates the white light emission. So that means this is again not a single molecular or single chromophoric emission, but rather self-assembly supramolecular based approach. There is one example exists based on single chromophoric molecule white light emission. So in this case, as you can see, linear stretched molecule, whether it is depending on the conformation, whether it is stretched or self-folded, it creates the white light emission property. So when you look at in this reports, there are two limitations exist in this case. One is their emission color changes over time due to unequal degradation rates of the emitters. And second is the efficiency loss also different for different chromophores. And that leads to over a period of time, the white light will become no more white light. So in order to overcome this, the best approach is to get white light emission from single molecule so that its degradation rate will be not dependent on others. So by that logic, it's difficult to get white light emission from single chromophoric unit. So far, to the best of our knowledge, there is none. So however, we were glad to see that in our case, we get white light emission regardless of single chromophoric unit. So as you can see in this, our molecule emission is various from WIPGR color. That is why the emission should be covering from visible region in order to see white light emission. So in order to understand the white light emission property in solution, we have studied systematically by varying the solvent effect, self-assembly property in various solvent effect. So as you can see here in SEM images, going from THF to DMF acetonitrile methanol, you can see that the self-assembly morphology clearly changes. We saw white light emission very close to white light emission in THF. So depending on varying the solvent, as you can see from CAE chromaticity values, you get different chromaticity value for different solvents, as these are mentioned here. And then in lifetime measurements, when we studied between acetonitrile and THF, we observed longer lifetime in THF of 10 nanosecond, whereas in acetonitrile 7 nanosecond. That makes it, that supports that the amide bond forms a hydrogen bonding, which is facilitated in more polar solvent like THF. Whereas when you add water into the organic solvent from in the DMF solution, when you increase the amount of water sample, then the white light emission shifted to blue shifting. Now, that is overall in solution, this compound exhibited white light emission. However, we wanted to test whether this compound can show white light emission in the solid state as well, because any electronic devices like organic light emitting diode, it should be mostly solid state. So, however, when we test this molecule emission in solid state, no emission was observed. Leave white light emission, but no emission actually. So, how do we then we were thinking, how do we make them white light emission again occur in solid state? Then we took the approach of nanotechnology. In nanotechnology, the chemistry or the property can be greatly influenced as well. So, one of the approach is that electrospinning instrument. In electrospinning instrument, you can take any organic polymeric material and a solution form upon injection. So it is a syringe actually. You take the solution here and then inject it through pressure. Where the injection needle comes out, there if you apply the high voltage in the electric field, then the immediate evaporation of solvent happens due to the electric field, and then the organic material forms immediate changes from liquid state to solid state. Upon going to solid state, due to the very narrow nanometer size of the injection, this outcome fiber will be in the size of nanometer size. So this nanometer size is very important, because usually nanotechnology works that any molecule or the atoms, when they go into from bulk material to nano size, that due to quantum effect, their property gets changed. Similarly, we expected when we make nanofiber, this molecule again might show fluorescence. Indeed, we were glad to observe that when we mix our compound 28% weight volume percent chromophore with polystyrene polymer of having 1 lakh Dalton molecular weight, their nanofiber showed white light emission. So here, this is the white fiber you can see here in bright field confocal microscopy. You can see the fiber, and upon exciting with the red light laser, you can see red emission, and then blue laser you can see blue emission. In green laser you can see green emission. I mean, when you change the laser light, this red, green, blue observance from the same fiber indicates these fibers are exhibiting white light emission. Similarly, in visible light, the polymer solution. Here is the only polystyrene fiber. Here is the 20% chromophore with the polystyrene fiber. So in solution with the chromophore, the solution shows red color, whereas here no color because of only polystyrene. Similarly, in UV lamp, here no white light emission shows, whereas in case of 20% chromophore, you can see white light emission in solution. Similarly, in fiber, you don't see here no fiber, you can see white light emission, whereas with the 20% chromophore, you can see white light emission fibers. So this indicates that we can generate nanofiber which shows white light emission, whereas the compound 100% compound in solid state does not show emission. This emission is, we suppose that this fiber, whatever the fiber forms, they are controlled by the hydrogen bonding stacking between amide bonds. This parallel stacking of hydrogen bonding network is the reason why we see the white light emission. So obviously, if we make a bioimaging, these fibers can be used as a bioimaging as a red, green, blue colors for monitoring cell applications. Obviously, if you want to use it for biological application, we need to test them for the biocompatibility. We indeed tested biocompatibility of these fibers using both normal cell as well as cancer cell. As you can see, the blue line is the normal cell line, which showed a very high biocompatibility up to 0.4 micromolar per liter microgram, whereas cancer cell line showed significant toxicity even at 0.1 microgram per liter. So this indicates that these compounds can be used for cancer cell treatment as well. That I'll explain the future slide. Now, when we move from this monochromophore, the previous compounds are based on monosubstituted tetracyanobutadiene actually. So the same compound without phenyl group here hydrogen. And we observed that these compounds showed some problem in the purification because they generally tend to undergo aggregation, supramolecular chemistry. Because of the aggregation, the monomeric form is difficult to isolate them. So we hypothesized that if we can replace this hydrogen with a substituent, bis-substituent, then we can avoid spontaneous self aggregation, and then by which we can control their emission property. So based on that, we synthesized series of bis-substituted tetracyanobutadiene, and one of the compound we got crystal structure where we observed that this compound again undergoes self-assembly of parallel stacking controlled by hydrogen bonding, two-dimensional hydrogen bonding, here one-dimensional, here one-dimensional. So this hydrogen bonding stacking, if you can view here in one c-axis, along the c-axis, actually they stack in a way of a donor in one column, acceptor in another column. So this kind of donor acceptor segregation is quite unique. It's very difficult rare to achieve this kind of arrangement. Usually arrangement will be donor and acceptor alternatively rather than segregating donor and acceptor. So if one can make donor acceptor segregation, this kind of crystal structures are useful in case of electronic devices application. For example, if you want to conduct the electron and hole and electron charge separation, you want to move electron in one direction, hole in another direction, then this kind of arrangement will be very interesting. So in that aspect, also this kind of molecules are good. And however, right now we are not focused on that application. So right now we are focused on the fluorescence properties of these compounds. So upon synthesizing these bis-substituted TCBDs, we tested the fluorescence characteristic. As you can see here, by changing the substituent R1 and R2 here, you can greatly influence the fluorescence nature, the quantum yield, as well as the absorption coefficient value. So only the compound number one showed the highest emission actually, whereas compound number 4 highest absorption. So since compound number 1 showed highest emission, we took that compound for further studies. And however, this compound number 1 emission is around 420 nanometer, which is not very longer redshifted absorption emission. So in order to achieve white light emission or bioimaging application, visible region emission will be very interesting. In that region, with that objective, we wanted to switch the absorption characteristic or emission characteristic for this compound. So in this compound, having bis substituted tetracyanobutadiene we chose, we again utilized the nanotechnology approach to alter their emission characteristics. For example, what we did is that we took pluronic F127 triblock polymer and then dissolved in water to form nanomicelle in presence of this chromophore. So this chromophore, when nanomicelle forms, due to hydrophobic nature at the core, this compound tend to aggregate inside this hydrophobic part, thus generating this di-aggregated nanomicelle, wherein the outer layer is water-soluble polyethylene glycol units. So this nanomicelle size is around 80 nanometer as confirmed by TEM here. So we may prepare this nanomicelle in water. This molecule is actually not soluble in water, whereas we dissolve this compound into acetone and then dissolve in water nanomicelle of this triblock polymer. Then this compound goes inside this nanomicelle. Upon evaporation of acetone, we end up getting this nanomicelle in water. So as I said, their absorption and emission property upon formation of nanoparticle is completely different. For example, here you can see the original molecule emission is around 440 nanometer, whereas the nanoparticle in the di-aggregated form, the emission is 600 nanometer. So we almost see 170 nanometer shift. So this is also clear from the visual naked eye visualization in presence of UV light. So in the neat compound shows almost no fluorescence here, whereas nanoparticle shows a very high fluorescence. So this observation, 600 nanometer observation, is very interesting for the use in bioimaging application in cells. So we collaborated with Dr. Regan Khan in our institute, who is my colleague. So he studied the bioimaging application for these compounds. So he basically injected this compound in the cells and then monitored through confocal microscopy, wherein we can see both the red emission as well as green emission from these compounds. That indicates their longer wavelength absorption chromophores. So this spectrum shows almost no emission for unstained cell as well as for the molecular compound, whereas the same compound in nanoparticle form you can see very high fluorescence here. And in order to demonstrate their application, we also demonstrated photodynamic therapy using this compound nanoparticle. So when we shine the light to the cancer cell line, the cancer cells are dying, whereas without light the cancer cells are surviving. So this indicates that using light and our nanoparticle chromophore, we can kill the cancer cell line. So that indicates here we use the chemistry of molecular chromophore and then nanotechnology approach to create photodynamic therapy material. So here is a perfect engineering of chemistry for engineering application. And then to demonstrate that indeed singlet oxygen generation, what is the mechanism behind the formation of this photodynamic therapy is based on singlet oxygen generation. In singlet oxygen generation, in presence of photosensitizer, our molecule is a photosensitizer. That photosensitizer, upon reacting with the triplet oxygen, generates singlet oxygen. That singlet oxygen can react with the DHN molecule and that then producing juglone. So this chemistry can be monitored through UV visible spectroscopy. If this chemistry generates, that means that in the cells also singlet oxygen can be generated, and that is killing the cancer cell lines. So I think my time is going to end. Dr. Rakesh, how much time I have?
It's okay. I mean, we still have half an hour, so
Half an hour, right? So
Yeah,
can I
yeah.
continue for
yeah,
fluorescence
please,
sensing
please.
also?
Yes, please. Go.
Okay, thank you. So now I would like to, so far I have been talking about fundamental research, how we can tune the molecular property of non-fluorescent to fluorescent molecule and their fluorescent molecule, again alteration using nanotechnology approach. And then using this nanotechnology approach, whatever the property we got, that we use it for the bioimaging application. Now I would like to show you how we can further this fundamental research can be used into translational research. So one of the main approach of using this urea functional group was to use it as a sensor that urea can be bound with some anion through hydrogen bonding nature. So that can, if it can bind with iron bonding, so that can be used as a sensor for various biological molecule as well, because the entire biological system is based on iron bonding approaches. So by that logic, we were looking for application. So one of the application is fluoride ion. Unlike fluoride ion is kind of quite unique. Unlike any other analytes, for example, mercury, arsenic, cadmium, these kind of common ions, cations, normally considered as a toxic metals, and they normally people wanted to remove them. So they have been various researchers have been shown long-time interest to detect them and remove them. Unlike these cations, whereas the fluoride anion is kind of unique because fluoride ion, their presence in very excess or very low, both are toxic. However, if they are in the optimum level, then they are good for our health. So that is kind of differentiate them between other anions or ions. So based on that, we found that fluoride ion presence in drinking water at 1 ppm is the optimum level. Their presence in higher or lower is not good for the health, human health. So as you can see here, this is the biggest problem right now in India. As you can see in Rajasthan, Telangana, Andhra Pradesh, Madhya Pradesh, Bihar, these are the states severely affected due to fluorosis disease. Fluorosis disease is nothing but, there are two kinds of fluorosis disease. One is if the fluoride ion very low, lower than 1 ppm, then one can get dental fluorosis. Dental fluorosis is not a life-threatening fluorosis, whereas if the fluoride ion is very excess, more than 3 ppm, then it can lead to skeletal fluorosis. Skeletal fluorosis is actually life-threatening one. What happens when the fluoride accumulated in the body, they generally go and bind, accumulate in the bones, in the knee, especially in the knee, in the leg or hand. Due to that accumulation of fluoride ion, the calcium bones get crippled actually. Due to this crippling nature of bones, the bone tends to get bented, and because of that the people become disabled for lifetime, and this is very bad. So this is irreversible actually. So this is very quite a dangerous disease, fluorosis. As you can see, according to British Geological Survey, throughout the world this fluoride richness in drinking water is present. That is mainly because of the ore, calcium fluoride, fluorspar ore present in the geological area. So wherever pink shade is there the fluorspar ore is present. Due to that, the land water is highly rich in fluoride ion. So in order to overcome this problem, there are two approaches one can do. If the fluoride is really very high, one has to remove them, and then even if you remove completely, you have to make optimum level of 1 ppm. That means you have to, if the level is very low, then you have to add fluoride and make sure that it's 1 ppm. So this is the solution. In US, actually the government distributes water upon maintaining this 1 ppm fluoride ion. So you will also seen many advertisement that when we use toothpaste, in the toothpaste, fluoride toothpaste, people buy it. Whoever have fluoride teeth color change happens, they buy fluoride toothpaste and brush it. So that means that fluoride is a very big problem actually in the world. As I said, the solution for this here you can clearly see if it is less than 1 ppm, it is dental fluorosis. If it is more than 2 ppm, skeletal fluorosis. In skeletal fluorosis is the very dangerous one. And in order to overcome this solution, the simplest solution should be you have to determine before drinking water whether the drinking water contains how much fluoride content. If the fluoride content is more than 2 ppm, do not drink it. That is the solution. So how do we know this? We cannot every time send the drinking water to laboratory in some city from rural area, and then after testing, after 1 or 2 months, you get the result and then drink water. That is not possible. So there should be immediate testing required. The immediate testing should be you take a filter paper, any paper, that paper you just dip it in the drinking water and it shows color changes. That means the fluoride ion is really high. So that will be if it is really high, then do not drink the water. So that should be the simplest and low cost method. So however, there are so far there are so many research have been going on last almost 100 years. Last 2 decades, extensive research is going on for fluoride ion sensing. Here I showed a couple of examples. So one example here is that in this naphthalene diamide urea attached chromophore, upon binding with the fluoride, shows color change in solution, and that too in organic solvent. This does not work in water. Whereas this compound, similarly, BODP attached with urea thiourea moiety, also showed color change, but not in naked eye, but under UV lamp. This is based on fluorescence mechanism. So that means you need a UV instrument or UV lamp. So whereas for a common man to use it in the rural area, the best would be not to use any electronic devices. So our main approach was is to develop a chromophore which can change the color, that can be monitored by naked eye, as well as not dependent on any instrument. So that was our approach. So here is another example where they use fluorescence based solid phase and color change. Again, the color is not contrast color, from purple color to light color change. So when we look into the literature, one of the drawback is that there is, though a lot of work have been reported in solution, solid state it does not work. So currently one German company sells a paper step test kit for detection of fluoride that is only works for HF, not for organic fluoride or calcium fluoride. So these are the drawbacks in the literature. So when we worked on this chromophore, we thought that maybe our chromophore can be tested for this application. So we chose several bis substituted, urea substituted, or thiourea substituted chromophore and tested for fluoride sensing using UV spectroscopy, and found that only compound 2 showed shift color absorption shift, whereas other compound did not show significant shift. So that indicates that only compound 2 having only phenyl ion showed fluoride ion color change. So when we looked into UV spectroscopy, upon titrating with fluoride, you can see that fluoride ion generates new absorption peak, whereas the existing peak decreases. Not only absorption, also fluorescence get enhanced upon binding with the fluoride. Then job plot, when we tried with the job plot, 1:1 fluoride and our chromophore binds actually according to Jaws plot, and association constant between our urea moiety and fluoride ion was found to be 1325 per molar. And then selectivity test also was studied using not only other common anions like azide, nitrate, acetate, phosphate, and fluoride. Within the halide, fluoride group, bromide, chloride, iodide, in all cases only fluoride showed color change. And most importantly, the color change mechanism is due to the deprotonation of this hydrogen atom attached next to the TCPD moiety, because among the two nitrogen NH proton, only this NH is less acidic, more acidic because of the electron withdrawing nature here. Upon deprotonation, due to the conjugation here, the color changes happens. That was monitored by NMR spectroscopy. In NMR spectroscopy, you can see that here the red and green proton, the green proton after adding one equivalent disappears, whereas red proton stays. So based on that, we propose that this NH proton gets deprotonated. And then based on DFT calculation, we propose that why in comparison to other chromophore, compound 1 only showed this fluoride color shifting. That is because the other chromophore has electron donor group in case of phenyl group, and that additional electron donor group, due to the additional charge transfer band, the any deprotonated species charge transfer peak get overlapped in case of electron donating group, whereas compound having no electron donating group showed color the charge transfer gap very much difference, that is 99 nanometer. So that makes it color very different. So here is the most important part, that is solid phase sensing. This is the most important we were looking. So we were happy to see that in water DMSO 1:1, upon adding 3 ppm of fluoride ion, you can see clear color change. Whereas even in 1 ppm, but only DMSO it works. Whereas in case of water and DMSO, only at 3 ppm the color change was observed. This work was recently highlighted in India Science News coverage. One can, if you are interested, you can see in YouTube the episode called Anusantanika 6H. In the case of Independence Day, this news was covered. They telecasted. So this success story was also highlighted in DST website. So in summary, we have successfully demonstrated urea as an efficient donor for CARE reaction, which enabled to obtain fluorescent to non-fluorescent push-pull chromophore. Unexpectedly, bis urea containing mono-TCPDs exhibited unusual single molecule white light emission, which was found to be mediated by hydrogen bonding induced self-assembly. And then bis substituted TCPD undergone further emission property by using nanotechnology approach, and we also achieved white light emission solid state sensing based on nanofiber approach. So overall, we transferred from molecular to nanotechnology approach to get some device active device materials. So I think due to time, I would like to close here. I will not be talking about catalysis today. Rakesh, can
Yes, yeah, thank you very much, Dr. Govindaswamy. Yes, it was a wonderful talk, and it's a very informative session on the organic molecules for for sensing applications, especially for the fluoride. And congratulations for such a success. Now you are also in the news. That's very nice to know. Very good. So there are a couple of questions.
Before that, Rakesh, I would like to give you acknowledgement section. Yes.
Yeah, please go on. If you want to present, you can present your rest of the things, I guess. You still have 15 minutes, but it's all up to you.
I would like to go for question answer as well. Otherwise, we may miss question answer session.
Okay, yeah, there are not many questions, maybe a couple of questions, but yes, please, as you are convenient.
So, I would like to thank my student, Mr. Arif Azandara and Dr. Gauri Jaimurugan. They're mostly contributed in all this work. Yeah, and I would like to thank DST for financial support. And collaborator, Dr. Ehsan Ali for computational, Dr. Regan for biological studies, and Dr. Muthukrishnan for electrical studies, electrochemistry. With that, this is my group. So with that, I conclude this talk. Thank you.
Thank you very much again. And any questions from the participants, please feel free. Yeah, you can.
Sir, good afternoon, sir.
Yes.
Sir, I am Dr. Syed Abdayar from Tamil Nadu, sir.
Yes.
Really, your session is very highly informative and very useful to us, sir.
Yes.
Sir, you pointed out, sir. What is the reason water containing excess amount of fluoride ions, sir?
That is what due to natural mineral, that is fluorspar,
Natural.
calcium fluoride fluorspar, that
Yes, sir.
dissolves in the river and lake actually.
Okay, sir.
Yes.
Because of natural resources, sir.
Natural mineral,
Natural mineral.
fluorspar mineral. Yes.
Fluorspar mineral.
Yes.
In India, what particularly in which areas are that is present in
Especially
higher
in
amount?
Telangana,
Yes,
in
sir.
Andhra Pradesh. In Andhra Pradesh, there are villages, almost 70% people affected cruises.
Okay,
In
sir.
Andhra Pradesh, Rajasthan,
Rajasthan.
Uttar Pradesh, even Haryana, Assam, there are several villages majorly affected actually.
Okay, sir.
Yeah, I think
Yes.
Karnataka is also facing this problem.
Problem.
Yes, Karnataka as well. They
Okay.
are
In
almost all
Tamil
the
Nadu,
states. Actually.
Dindigul area
Tamil Nadu
is
also.
facing, yes, in Dindigul area they are facing the same problem, sir.
Yes.
Yeah.
Yes.
Sir,
Actually, my laptop power is gone. Almost may go to shut down.
Okay. No, but it's okay. Great.
Sorry.
Thank you.
thank you. Sir, could you share your presentation, sir, PowerPoint presentation, sir?
Sure, definitely.
Okay, sir.
I would, yeah, okay, great. Yeah, please.
Thank you, sir. Thank you very much, sir.
So, yeah, let's thank Dr. Jayamurgan for his wonderful talk. And if you have other questions, I am sure he would be happy to, answer you through email or maybe by phone. A few
Yes.
questions, not only 100 questions, of course. And it was really an honor for us to have you here today. And I expect and hope that you will also be available in future for such wonderful talks. Thank you very much. So, thank you very much, everyone, for being with us for the whole day today for the 2 sessions. And tomorrow, today it was, I guess, very informative. In the morning session, we learned about the e-waste, which is really a major concern. And it's good that Professor Shishir Sinha brought it up. And in this afternoon session, again, this was a wonderful research on, especially on the fluoride ion detection. That is just eye detection. You don't need any fancy equipments and all that. So tomorrow also we have 2 wonderful sessions. And I hope and request you all to please be present on time tomorrow. And we will share the feedback during the second session. And the certificates will also be attached with the feedback. So have a wonderful afternoon and see you tomorrow. Thank you very much.
Sir, tomorrow when you will conduct the test, sir? Sir, tomorrow? Which time, sir? Sir, organizer, sir? Sir, organizer, sir?